What's up? Welcome to today's live stream. I'm William. Today is December 14th. Only a few more days, I guess a few more weeks, a couple more weeks left in the month. Been working. Just got off. Well, not really just got off. I just walked my dog and came back. And then I spent about 30 minutes or so after work trying to develop out or flesh out this idea, like make it formal. This concept of a DAO, a data access object. It's not the other kind. It's my own flavor of it. And I've been fighting the TypeScript compiler. It's been fun. Not really. Anyways, I just decided to go ahead and get the stream started because I'm like, if I don't start now, I won't do it. And we may be doing a little bit of development today, maybe. Or maybe I might do a little bit of JavaScript stuff. We'll see. I don't know. Oh my gosh, I'm tired. Let me go ahead and switch over to the screen. So I have these types that I've developed. Just let me close some of these things. Excuse me. Yeah, so I have I've been building this up from like core concepts, I guess maybe. So I have this idea of a unit success result, and this is to represent data access, whether it be via a web API, files, databases, whatever. The point of a DAO is to be, or is to make it so that the end user doesn't have to care about how or where or what the data is. It's just like a function. So I have this type here to represent just a void type. I call it unit because it's functional. Then I have a different version of that called data success result, and it's literally the same thing except there's also a data component to it, so it's generic. And then I have this concept of an error result, which is going to return false. So you see here that we have a discriminant. So what I have here is a discriminated union that so far it seems to work. You know, the types are aligned and it seems happy. I have this idea of a DAO function, and it's just actually here, let me make that even clearer. Actually, okay, a DAO function is literally just a function that returns either a promise of a type or a type. It could be either or. In fact, let me go ahead and make that very painfully obvious. So this can also be, this could be either that or, wait a minute, what did I just do? All right, we're gonna rename this to a DAO async function. Then I'm gonna create another version of that. I don't know if it's obvious. I have not actually finished this. I'm freaking dealing with a bunch of things not working, and it's very, very, very annoying, to say the least. Maybe we won't export this. Yeah, whatever, we'll keep the export. So a DAO function would be the composition of both of these things. Except maybe it's not happy with that. Oops, I probably should also include this. I don't know. I'm gonna have to do a little bit of soul searching and like figure out why I can't do this. But for now, I'm just gonna do all this and get back to what I have. So it took me a while. Like I said, it's taking me like 30, 40 minutes just to get to here. It wasn't all working. Then I have this concept of a DAO middleware, which this is actually what's causing me all the issues. So I might take this out. I wanted to abstract away error handling, logging, retry logic, like all that kind of stuff. I wanted to abstract that out so that whenever I define my DAO functions, they can be clean or pure, whatever. They're technically not pure. They can be cleaner. And then I can go and compose additional functionality. So that was this idea that I have with this DAO middleware, which is new for me. In the past, I've never had the concept of a middleware. What I would always do is basically just re-implement all of the stuff in each one. And I have an example of that in another project, but I don't feel like opening it right now. So yeah, I have a DAO middleware, and its whole purpose in life is to allow me to extend a DAO runner, which we'll get into this in a second. I have this DAO error, which is literally just an error. I extend it, and then I give it some like this DAO error, and this allows me to discriminate in a try catch and my business logic. I can check to see if it's a DAO error, and if so, I can handle it accordingly. And this is where magic happens, except right now it's not magic, it's pain, because it's technically not working the way I want it to work. So I have this DAO runner, and this is a class, and the only reason why it's a class is due to ergonomics. I want to be able to say DAO runner dot run. That's it. So the only way I can get a static function is to put it in a class. So that's what I did. It takes a function, which is a DAO function, and then it takes a collection of middlewares as well as the arguments. The arguments themselves are the arguments that go to this function here. And I still haven't figured out a way to get the type information from this function, like to figure out what are the arguments to that function, and get that here. That's actually what I want here. I'll figure it out eventually. Right now, I am literally just putting in a placeholder type where it's just args extends anything. It just needs to be an array of something. So, 0 or 1 or more arguments. And then here, this is where things get a little bit tricky. So I'm having, and I don't think I want to continue to do it this way. We'll see though. I have two concepts here. I have something called a wrapped, like a wrapped DAO function, as well as a function that wraps a middleware, which is going to return a wrapped DAO function. The issue is that at the moment, the way I have this working is that I'm wrapping a function ahead of time, and then I'm passing a wrapped DAO function into a wrapped middleware. So, yeah. Yeah, that's one thing I don't like, but I don't know, I'll get there one day in the future. Other things that's going on is this result thing here, where all I'm doing is I'm calling the function with the args that are passed in. This is why I want to make sure that I type this correctly. It won't extend any right here. This will actually extend whatever the DAO is. So I had to go into the keys and then like figure out the type of the value that corresponds to that key. I'm gonna have to read the TypeScript docs to do that. I have not done advanced TypeScript stuff in years. It's been at least 3 years since I've done advanced TypeScript stuff. I don't consider what you see here advanced. This is like normal for me. All right, so after that, I'm returning this right here, which is a DAO result. But notice here that I'm not really discriminating on whether or not this is a function that returns a unit or a value, right? Because a DAO function could return. All right, here's that. All right, I just figured out the issue, or one of the issues. Just figured out one of the issues. So a DAO function can return either a promise of t, or it can return undefined. That's one of the issues. So it looks like talking through it has helped me illuminate one issue. So why did I do that? Well, if I get back undefined here, then obviously there's no data. So I'm gonna have to check, right? So we'll say result, and we'll say if result is undefined, then I want to return something else. We could do that as a ternary actually. So we'll do, we'll say result is undefined. Yeah, I guess we could do it this way. I really think I should be checking the type of the result. Yeah. So we'll say if type of the result is equal to undefined, then well, we'll invert this. So we'll say if it's not equal to undefined, we'll return that. Otherwise, we'll just return my success true. All right, why is this not formatting? Let me comment out the things that's broken. Okay. And then here, in this case, I'm not looking inside of the result to see if it's actually a failure. And what I mean by that is that exceptional errors, things that I have no idea that can happen, that's going to result in a success false. Otherwise, it'll always be true. So technically, my types aren't covering what it is that I would like, but yeah, I can iterate to that. Anyway, so in my catch, you notice that this error is still unknown because TypeScript, I guess. Also, I have no idea. Like, it would be impossible for me to know what kind of error this is. So what I'm doing is I'm creating a new DAO error, and then as an option, I'm just giving the original error. So if I really want to see the internal error, I'll just look at that. Then here's where things, again, this is the tricky part, where I'm iterating through all of my middleware functions, which I don't know if my type is right yet. That's bugging me right now. Anyway, I go through all of my middleware functions, and here you see the first reason why I had to wrap it up here. It's because this wrapped middleware thing here expects it to be wrapped, and I couldn't get this to work without wrapping it first. So like this is like the fourth iteration of this function, and I'm at a point where I'm just like, I don't know if I can continue doing it. Anyway, then I return my current function. You know, this is the function after I've wrapped all of the middlewares on it. So it's like this, just think of it as a function wrapped around the function, wrapped around the function, wrapped around the function. And then I pass in my arguments, and then like it goes one after another. So like as it executes the function, it gets back the actual type. It's not doing that yet. That's what I think I need to figure out how to do. I'm going to get back the actual type, and then I need to pass that actual type on to the next middleware function. Actually, you know what? Maybe I have a better way of doing that. Anyway, I guess I'm gonna have a guest come on soon. Give me a second. All right, so, oh wait, do I need to join the meeting? Am I not in it? Hold on, it says I'm connecting, okay. Well, all right, so I guess I am connecting. Okay, maybe I want to share my camera. Test 1, 2. All right. Hopefully that's working. Hello, how are you?
Hello.
Oh, give me a second. Let me move myself to another screen. And I got to make sure audio is working. I'm gonna ask you to say some stuff in a second. Just give me a minute. All right, say something.
Can you hear me?
Yeah, all right, we're good.
Hey.
How you doing?
Doing good. How are you?
I'm all right. Just stressed out. This.
Oh, wait, why?
Cause TypeScript. It's I don't know. Like I'm trying to formalize a design pattern that I've been developing over the past 8 or 9 years, and I'm trying to formalize it in types and TypeScript, and running into all kinds of issues. Part of that is because I'm not only formalizing what I've been doing, I decided, which you should never do, just this is a fun lesson for you, I decided that I'm going to extend my idea while I do it. So I'm trying to add this concept of middlewares, which is something that it's a design pattern in other frameworks. So I'm trying to do that. Give me a second. Let me share my screen. I just realized that you can't see what I'm doing. All right, let me move this to here. Okay. All right, you can see what I'm looking at, right?
Yes.
All right. By the way, you're going to be sharing your screen for the most part. I'm not going to be doing it. So you're going to be typing stuff eventually. But this is like, so far, this is all the easy part, like just defining my interfaces to my base types. But I'm having issues with these things right here. And I've been iterating across these things for about 30 to 40 minutes now. So I'm frustrated that it's not working. And if I come here, see here that this is like, I can't return this type because technically I can't return this type. And I understand why. It's just, I don't know what the correct types are, which is annoying. And then there's this other thing here, which I was about to do until you messaged me. I was like, oh, let me go walk Rosca. So, yeah, let me back up. The whole thing that I'm trying to do is this thing that I call a data access object. And its whole point in life is to abstract data access so that the end user doesn't have to care if it's across a file, if it's using a web API, a database, or any type of like data store. The point is that the end user inside of business logic should not need to care. And part of the reason why I'm doing this is that a lot of complexity that I deal with is dealing with data access. Stuff like error handling, retry logic, rate limiting, logging, like all that kind of stuff. Observability. There's a lot of things that I found myself doing all the time, and I would like to abstract it and build generic functions to handle that. But because I want to do it in TypeScript, I need to figure out the types. so yeah, that's what's going on. Anyway, I'm a.
Did you do it before in a different language?
So before, I didn't have generic ways of handling any of these things.
Oh.
It was just I would just do the thing without worrying about having types that other people could use that they could then compose to do more interesting things. So this is more of a form, like that's why I say this is formalizing the idea, where it's now supported by, it's now supported by the type system versus just me as a developer just knowing that I need to do X, Y, or Z. So there's this idea that if you want people to make mistakes, give them the opportunity to do it. So if you have types, if your types are correct, then it becomes impossible to write incorrect code. I'm using quotes on purpose. You can only write code that satisfies the types. So you could call it guardrails if you like for developers. But yeah, I'll go ahead and let me just get away from this before I get upset. I'm going to stop sharing my screen and we'll jump to your screen. Give me one moment. All right. Yeah, you can go ahead and share your screen now.
Wait, 1 second. What? What? Let me minimize this. Wait, did it work? Can you see my screen?
Nope.
Oh, you can't. 1 second. Mm, Share. Okay. Oh, okay, there you go. Sorry, I forgot to click the actual share button. Um,
Yeah, yeah, it's a two-step process.
uh, yeah, I was just like reading up on this. But yeah, I haven't done much, outside of just reading stuff.
Oh, that's fine. You said that you were learning, I guess, JavaScript stuff. So I guess we should start there because I actually don't know what you know or don't know. Although this is also TypeScript, which I can help you a little bit more on the
Mm,
TypeScript front, even though I'm having issues with my TypeScript stuff, which is different. It's more like library developer type stuff that I'm dealing with.
mm.
But yeah, so let's start off with what questions do you have based off of whatever you've done so far?
Uh, so for JavaScript, I'm kind of just reading. Let me see if I can get to it. Nope. Oh no. Okay, I'm still getting the hang of the keyboard shortcuts. Anyways, I'm just kind of reading this uh online book, I guess. Um called Eloquent JavaScript. Not very far. So yeah, I'm just like trying to do the exercises and stuff. So not too much. I guess some of the questions maybe like for some of the loops, like for the do while, the do, if you write it and like there's different ways to get to a solution or result.
Mm-hmm.
Um, is there like a difference in runtime or how complex, like based off of the different loops that you choose?
Uh, no.
Oh, okay.
So there's technically only one kind of loop. All the other loops are syntactic sugar, meaning
Oh.
that they are basically the same thing. They just are different ways to call it. But there are different type. Like there's looping, and then there's I guess enumeration or iteration. They
Mm.
are slightly different. So maybe we can go over that, I suppose. So in order to do that, let's start a new node project. So what you'll do is open up your terminal and you'll create a new directory, and you can call it whatever you actually call it fun with loops or something to do with loops. So yeah, go ahead and do that. Open up terminal and create a new directory, and make sure you're doing it in your top level code directory.
And would it be from here, this console, or
Yeah. From here. So do Control U to go ahead and clear everything, or that too.
Control U?
Yeah,
Oh,
and Control L will clear your screen if you care. So
Control. Oh, cool. Okay.
uh-huh. All right. So here, just do dot dot because I see here. You see in your Chrome in the top window right there where it says code/my remix app. It's showing you
Mhm.
your current path. Now,
Oh,
mine you can configure your shell so that it shows you inline, but we'll leave it alone for now. So in this
mm,
directory, your code directory, you want to make a new directory. Call it something. I don't know what you want to call it.
mm,
Let's
eh,
call it AAA to draw from the fact that it does not matter what the name is.
eh.
All right, go ahead and press enter and cd into that directory. All right, so inside of here, you'll do npm dash or space init space dash y.
Um,
npm like node package manager. Even though technically
oh,
npm is not an acronym, they're very, at least when they first came out, they were kind of anal about that. They're like, npm is not an acronym. It's like, okay, we got it. It's
oh.
so it's like, but
Wait, I thought it was an acronym.
well,
Doesn't
yeah,
it?
well, that's my point. It's like if you didn't want it to be thought of as an acronym, then why does it spell out no package manager?
Uh, sorry, what was the last couple parts?
A nit. And before you do it, do dash dash help.
Oh,
All right, so you see here, this shows you all of the commands that are possible. And
Mm.
this also gives you how you can learn more about a particular command. So you should be able to do npm help and then init, and that should tell you what it does and the options that it has.
Did you say it?
Init, initialize.
Oh, oops.
So when you run this command, that's what it's going to do. It's going to create a package JSON file. And if you do the slash that's next to your shift key and you type in -y
Yeah.
and enter. All right, so you see here it says skip the questionnaire altogether. So that should imply that if you don't include that, it's going to ask you a bunch of questions and you're going to have to deal with that. So this is what you're running. You're doing npm init-y so that we can create this package JSON file. So to get out of here, press Q.
Oh, okay.
No, not a slash. You use slash to search in the page of you're in. Here it's just -y. All right. Go ahead and do the thing. All right, and you see here you get a file. We probably should have did a get init first, but it doesn't matter. It doesn't matter that much. Actually, yeah, go ahead and do get init. Git space init. The reason for this is that maybe you'll make a mistake and maybe we'll want to go back. This implies that we'll have to commit, otherwise it doesn't work. So yeah. It's the same like subcommand init. It's a common thing for most things because we had to initialize something before we start. No, not -y, just init.
Like that?
If you're curious to know what are the flags that you can pass init, you go to Git documentation and you do that. But for now, just press enter.
Is it similar to the npm help? Could I do it like git help, or would I have to?
No. Git has man pages, so you would do man space git dash init, and that will show you the help file for Git.
Gotcha. Okay.
All right, so now that you have a file or you have a project per se, let's create a file. So let's call it I don't know, loop, I guess. So you'll do touch space loop.js. We're going to use JavaScript for now because it'll be too much effort to set up TypeScript here. All right, now open, well, what do you have? You probably have VI. Yeah, type VI and then loop.js. And remember tab complete. If you're typing it, then you're doing it wrong.
Oh.
All right, so now you're in a text editor. You can leave your mouse alone. It's not going to help you here. You need to enter into insert mode. So the first command that you're going to learn is I. So if you type I, it'll put you in insert mode, and you see there it changes the mode. If you want to get out of that mode, you can press escape. And if you want to get back into that mode, you press I. All right, so now this will allow you to insert text into your file. So let's just put a console log hello. This will be your first, I guess. Well, it's not your first program, but close enough.
Oh, whoops.
All right, and press enter. It's just going to insert a new line. Okay, now you'll press escape, and then we're going to enter in a command. So to get into the command palette, you'll press colon or shift colon, whatever it is.
Shift colon.
Okay, so now we're going to give it the command. We want two commands. We want to write, and because we only have this one thing, no, not yet. So we're going to write first, and then because we don't have another shell, like, or some other things set up, we're going to quit so that we can go back to our shell environment and run the script. So to write is W, and to close it is Q. So you'll just do WQ for write quit. And press enter.
Do I have to press enter?
No, you do WQ.
Oh.
And press enter. All right, so now you have a file, so let's run it. We'll do node loop.js, and you should get back whatever you wrote in your script.
Yeah, I keep forgetting about the tab complete.
Welcome to the stream, Eddie. I mean, I get messages on my stream, bro. It's just FYI.
Oh, nice.
Oh, not you. You're talking about, yeah. My bad. You're not watching the stream, but they're like, yeah. I'm sharing my screen, which means that everyone else can see my screen. They're seeing your screen too, but because they're seeing my screen as well, all of my notifications that go off, they happen up on my screen. So yeah,
okay.
Somebody was messaging me, and I was like, for what it's worth, everyone's seeing that message, bro. All right, so yeah, you have your file that's doing some stuff. Now we're gonna open this in another text editor, so you can go ahead and close the window behind you, the Visual Studio window. To do that is Command Shift W.
Command Shift.
And if that doesn't work, all right, good. All right, and now inside of your terminal, you'll just do code space dot, and that'll open up the same editor, but it'll open it in this directory.
Good.
All right, cool. Yep. Hopefully you trust yourself. All right, so let's open up the loop.js. And we're going to do the first loop. Do you know how to do comments in JavaScript yet?
Yeah, dashes?
Yes, or you could do command slash.
Oh, and oh, nice.
And here I guess we'll start with the first type of loop. We'll start with the easiest one to think about, which is a while loop. So just go ahead and say while loop. All right, so a while loop, like I said, is the easiest one. The reason why is because a lot of times, well, not a lot of times, you very rarely have to set up any type of state initially. So they're really good when you're using things that don't require state. Oh, if you want to get, let's get this set up so that if you press Command J, it'll open up your, whatever the thing is called. I don't know what it's called. All right, so if you see that hamburger menu that's on the right side.
On the right side.
Of the window that's just open, yeah. And okay, never mind. How about right click in that top part, and yeah, right click there. Panel position. And right or left, it doesn't matter, just put it somewhere. All right, so now you can expand it out. So now we'll be able to run whatever you're doing. And we're not gonna have a tool yet. We'll have to install other stuff if we want to be able to have it automatically run as you like change your code. But for now, we'll just type it manually. It's not that big a deal. All right, so first loop is a while loop. And the structure is, well, you're first going to use a keyword, which is while. So you can go ahead and do while. And one of the cool things about while loop is that it's really easy to do an infinite loop. Infinite loops are really important when you are doing things that you don't want to end. So for now, we're going to say while true. Just put true inside of parentheses.
I missed the
true
part where you said
true.
What is the parentheses?
True.
Oh, cheers. Well.
All right, and then you're gonna do the brackets, the curly braces. And why don't you go to line 1? So just move your cursor up to line 1, press Alt, hold it Alt, and then press arrow down until it gets to line 4.
Arrow down.
One more. All right, save it. All right, now go run it. See what happens.
Hmm. Hmm. To run it, do
You're going to use
uh
Node.
oh, Node
The name of it.
JS?
Yep.
Yeah.
So it's looping right now. You may not be able to tell, but it's infinite looping right now, and it won't
Right.
stop until
Yeah.
you well, you can send the OS like a signal kill. So press Control C a couple times, and that'll send out. Yeah, there you go. All right, so you see here, it's really easy to do an infinite loop. Now you may be
Right.
wondering like, well, what if I don't want it to do an infinite loop? What if I want it to stop if I hit a certain key or something like that? That's what while loops are really good for. So you could say like while the key pressed. Don't actually put this. It's just like you say like while this key isn't pressed, always run this loop. So if you think of an example like a game, for instance, maybe there's a certain keyboard command that you want to actually exit the main game loop, and you can do that there. All right, so yeah, this is probably the simplest while loop you could do, which is you just throw in true and then you get infinite looping. Now we're going to add some stuff to this. So maybe trying to think of the best way of doing this. Okay, let's make a commit. There's a little thing on the left hand side that says 2.
Uh,
The left, that's the right.
oh, I see. Okay.
We have to give it a message. So this is an infinite loop. Yes. Just open git log. I guess see what happens. All right. Well, it looks like you haven't set up Git yet, which we could do that now, I suppose. So what you could do is do Git. What do you have a GitHub account?
Yeah.
All right. Go open up Homebrew and do brew install. Maybe is it like GHCLI? Maybe GitHub CLI. I don't know. Maybe you have to go to Google. I don't know the name of it. You want to go look up whatever the tool is called because it may not be that. So just Google GitHub CLI.
Oh. Let's see.
No, CLI.
Oh, CLI.
Not Git, just CLI. Git and GitHub are two different things. We want a GitHub CLI, not a Git CLI, because you already have a Git CLI. That's what Git is. Yo, what's up, Kyle? How you doing? Oh yeah, I see. I just added you, bro. All right, yeah. Oh, it's GH. Okay, so yeah, just go. Yeah, type that. It's GH. I didn't know it was GH. I'm surprised they were able to get GH.
Isn't that still a country code?
GH? I don't know.
Oh, you're talking about GH, the command. I see what you're doing.
Yeah, I'm like, what
I'm catching
country?
up. I'm catching up.
Oh, but yeah, you should be. Well, now don't watch the stream, cause like Zoom is actually like real time. The stream is 20 to 30 seconds behind.
No, that's fine. I'm here.
So the reason why I'm having her install this is because you can do. Here's what you want to do: GH login, and that should set up Git on your system. Hopefully, maybe we'll see. It's GH login.
GH login?
Yep. or maybe it isn't. Scroll up. These are the options. One of them will be it. Oh, maybe it's auth. Maybe try that. GH auth. No, like scroll up.
Oh.
You see that command that says auth?
Oh,
All right, so it's login. So yeah, you'll press up and then space login. So I had one of the things, right? It's a sub command. So yeah, we'll do login. Yep, enter. There's no mouse here. You can leave it alone.
no.
I know the urge is strong. You're like, oh, I gotta use this mouse. No, it's GitHub. Just press enter. Enter. You don't really have to change anything. Just press enter. Yep, enter. Enter. What are you up to, Kyle? Oh, I guess he's gone.
No, I'm here. I just got done cleaning up after dinner. I'm hopping back on building a development workstation for a offline air gap system, if that makes sense.
It does. The code is in your CLI.
It's I see it.
Well, Kyle, I guess this could also be your lucky day too. If you have questions about JavaScript or whatever node,
Whoops.
this is the one.
This is the one?
Yeah, this is the one.
Requested format. What?
Just so you know, no one can see what you're doing.
I don't know why it's not.
That's the issue right there. It says it sent it to your email.
Oh. Second.
That's interesting. Do you have? Oh, you must.
That's
not
odd. Yeah.
I don't think she has two-factor or anything enabled.
I got force.
Well, that's because we worked there. All right, now you.
Yeah.
I think now you do that code, the ed whatever.
Oh, okay.
You just type it. It's not that hard to type. Or you do that. All right, cool. So we're gonna do the things, and hopefully you're all good. Okay, so now let's go back to your CLI, and we want to do up, and then delete whatever that last command is, and do setup -git. No. I'll say it again. You want to just and type setup -git. You're gonna do the command?
Oh, my bad.
It's not that. You see the command set. These are your options. It says log in, log out, refresh, setup git, status, switch, and token. The one I said was setup git.
Oh.
But that's not what you're typing. Your line says gh auth -git setup git, when it should just say gh auth setup git.
Oh.
Spelled the same way that you see it in the list of available commands.
Wait, is this not it? Do I have a? Oh, I see.
You're not logged into any GitHub. Oh, okay, so I guess you get to do that again. It looks like it didn't actually take. What the hell is up with my music? What the fuck? It's like skipping as if, I don't understand. Why is it doing that? All right, cool. So then you'll do that thing. So it says auth is not a git command. The hell? Did we just find an error? Or did you type get? What did you type? Press up. I wasn't looking at what you were doing. Yeah, that's why. You can't do get.
Oh, that's
You're
right.
using the GH. All right, cool. Now we hopefully have get set up. Maybe we'll see. All right, cool. Now let's go back to our loop and let's turn it into not an infinite loop. And we're going to do that by introducing some state. So on line 1, you're going to put a new line after 1.
Oh.
And define a variable. Doesn't matter what you call it. Just type a character on your keyboard. It doesn't matter what you call it. You can't say let var, because var is a reserved word in JavaScript. So variable names can only be named things that are not reserved words. Certain reserved words are like const, class, let, var, function. What are some other ones? Break, case, switch, yield, and await, async. These are all reserved words that you can't use. So your line 2 is wrong. You can't have let var. But let's use let. We're never using var here. We're going to use let. Erase var from your, I know in that book it says var, but ignore that. You're never using var.
Oh. So just X?
No, let.
Oh, my bad.
Zero. All right, so you don't need a semicolon. All right, so at the moment we have some state, but we're not using it. So maybe let's make it so that the thing that controls the end of our loop is this X. So we need to turn that into an expression that evaluates to a Boolean. The way we can do that is we could use a Boolean operator, or we can coalesce it to a Boolean. We're not going to do that. Actually, we are going to do that. Go ahead and put X inside of there. And you're going to learn your first thing of why JavaScript is whack sometimes. All right, save it and run it.
Oh.
Command or control tilde.
Oh.
Thoughts? I see you thinking. What's running through your head? You got to say something.
Wait, how come it didn't? Is it not Node?
Yeah, it's Node. It ran.
Oh.
So here's your first lesson. In JavaScript, because there's no types, things behave a little bit strangely. 0 is interpreted as false.
Oh. So it just never runs?
Well, that while loop only runs while that condition inside of it evaluates the true. And because false is not true, the thing will never do anything. Now, if you want to get it to run, put on line 2, change 0 to 1 and observe what happens. Look at that, you get another infinite loop. So what do you think that must mean? Actually, before you go, like, put -1 and see what that does.
Oops.
Notice that you get an infinite loop. So your first thing to keep in mind, at least when you're using JavaScript, is that any number that's not 0 is going to be evaluated to true.
Okay.
This is if you've ever heard of the term falsiness or truthiness, that's what they're getting at. So 0 is falsy, meaning that it's interpreted as false. Whereas any number that's not 0 is truthy, meaning that it evaluates the truth. Does that make sense? No, but I mean, that's, it's JavaScript. So now you know. So when you have issues and it's not working the way you expect, now you get to think about, well, is this value truthy or falsy? And all that kind of good stuff. All right, so yeah, now we're gonna actually use the state. So we've already put x in here. So let's say while x is greater than 5. Well, you gotta put it in the thing. Now, before you run this, what do you think's gonna happen?
Well, this is false, right?
Yes.
So there will be no hellos?
Yeah. All right, save it and see. Okay, so we're good. So now let's change it to less than 5 and see what happens. Well, or not just see what happens. What do you think is going to happen if you set it to less than 5?
This will always be true?
Yes, so let's see. All right, so now we want to get this such that this loop ends whenever x is, like we want to start doing something to x so that this loop will eventually end. So instead of logging hello, let's log x. So just put x in place of hello. The whole thing, not the whole hello. Like yeah, there you go, x. All right, so if you run this, what do you think is going to happen?
We'll just see instead of hello, an infinite -1.
Maybe. Let's see. So this is what I want you to get in the habit of. Like, don't just run it and just like think about it. That's really the only way to truly learn how these things work.
Gotcha.
Sorry, I'm organizing something. Give me a second. Put that here. What the fuck? Okay. Why does this is really annoying. Okay, all right, cool. All right, so we get a bunch of -1s. So now we want to get it so that it's actually going to do something. So I'm going to show you 2 ways of incrementing values. The first one is just put ++ at the end of that x. No, not that. Yeah, that x. Yeah, there you go. Now, what do you think is going to happen? Like, what do you think the output is going to be?
It will go -1. No, hold up. It'll be 0 for the first one, maybe, and then 1, 2, all the way up to 4.
All right, let's see.
Well, actually, it doesn't reassign it to x, so this is still an infinite loop. I think.
Let's see. Save it and find out.
Yeah.
We'll explain why it's what you see.
Oh.
All right. So this ++ is shorthand. This increments the value, but it's a special way to increment the value, which is why I generally don't tell people to use this. So I want to get it. I want you to change it so that it will do what you thought, which was 0 to 4. So what you're going to do is change that x++ to ++x.
++x.
And now rerun it, and that should give you the result that you initially thought that you would get. Except you get the 5, and there's a reason for that. So this one of them is called a pre-something incrementer. I don't know what the pre is. I'm going to call it a pre-increment, meaning that it's going to increment the value before it evaluates it. So if you were to read this from left to right, we have console log, and then we give it an expression. Well, expressions must be evaluated. That's why they're called expressions. So the question is, what order are we going to evaluate? Are we going to evaluate and then increment the value? Are we going to increment the value and then evaluate, which is just return the result of that evaluation? So plus plus x, when you call that, is going to increment the value, and then because that's a value and you have it in console log, it'll then print it. Whereas if you do the post version of that, it's going to print the value and then increment it. But you've already printed it, so it's 1 on the next one when you come back. And the reason why it goes to 5 is because again, it's happening after the fact. So by the time you get to let's say you get to line 4 and it's 4, well, we're going to increment it, so it's going to be 5, and then it's going to loop back around, and well, is 5 less than 5?
It's not though, right?
It's not. It's false, meaning that the loop terminates, which is why you get 0 through 5. It's because like 4 is less than 5, so the loop necessarily has to go again because it's less than 5. Gears churning still?
So the actual x is still 4 at the time, and that's why it does the 5.
Yeah. So let's step through it. All right. So on line 2, initially we set x to -1. We go into our while loop. X is -1. -1 is less than 5. True or false?
True.
All right, so I want you to write that on line 7. That's a comment or something. So we'll say -1 less than 5. True. All right, so because it's true, we're going to go into the body of this loop, which is line 4, and we're going to print something. So what are we going to print? Well, we're going to say console log, and then we have this plus plus x. So what we're going to print is whatever x plus 1 is. So that's going to be -1 plus 1, which is 0. So we're going to print 0. And then on the next iteration, so we'll put another comment. You can just copy what you have and kind of change the things as you go. All right, so on the next one, we're going to, because we've incremented the value, it was 0, so it's now 0. And you're going to ask the question, is 0 less than 5?
Yes.
All right, well, go ahead and it's true. So now we're going to do the same thing. It was 0, but we're adding 1 to it. So that becomes 1. And then you'll copy that line, and hopefully you'll see a pattern. We're going to take the last result, which is 1, and we're going to ask the question, is 1 less than 5?
Yeah, it's still less than 5. So then this is 2. Okay, so then
keep going. Like, you're not done. Copy and paste more until we are done. By the way, it's already in your clipboard. You don't have to keep copying it. You just press paste. And you just change the 2 things that need to change. So in this case, it's going to be 2, 3. And then you'll paste again. It'll be 3, 4. All right, so this one is going to be special because this is where I think you're getting hung up on. The question is 4 less than 5?
Yes.
Okay, so what are we going to have to print?
Yeah, the 5.
All right, now we're not done. We have one more because we haven't checked to see if x is less than 5. So let's do it again.
Right. Okay. So then this would be false, and it won't just exit, right?
Right. So look at your output on the right, like, you know, your 0, 1, 2, 3, 4, not that one, the one
Right.
that you wrote. You notice that that's what the computer just did. So it necessarily has to go to 5 because we're incrementing it before we evaluate. Whereas if we whereas if we evaluate and then increment, now it actually has the value on the next iteration of that loop. So let's do the same exercise again, but we're going to change it from a pre-increment to a post-increment. So on line 4, you'll go from whatever that is, plus plus x to x plus plus.
Okay.
Now you're going to keep that. We're going to start a new one. So go on another line or somewhere else. Same thing. We're going to paste something. So the question is, at the beginning, it's -1, right? That's what x is. Is -1 less than 5?
Yes.
So that means that we're going to go forward with the loop, which is on line 4. So now this is where we get into this, the post increment. So when we evaluate, we're going to print out -1.
Okay, and then it just adds.
It's going to add one, but you won't be able to see what that is until later. So let's don't skip steps. That's how you get confused. Just do the process and trust it. So do what you just did.
So,
let's make it clear that you're adding once on line 15. What I want you to do is, like at the end of that line, do like a, I don't know, like a, just put like +1, I guess. And then do that on 16 as well at the end. So that it's clear why we're going from -1 to 0.
Okay.
So this is a special place right now, right? So we now have 4 plus 1. So we're going to go to the next iteration of that loop. So we're going to say, is 5 less than 5? Now you'll notice that your output is the same as what the computer gave you, which is -1 through 4. Does it make sense now?
Yeah.
Okay. All right. So before we go to like, there's a special loop for this. It's syntactic sugar. And we'll get into that in a second. I wanted to first talk about the difference between a while loop and a do while loop. They are literally the same except for one key differentiator. A do while loop will execute the loop body at least once. Whereas a while loop, it's 100% dependent on the condition. So if you have something where you want the thing to happen at least once, use a do while. A good example of that could be a game loop, where it's like, obviously you want to start the game loop and then decide if you want to keep going. So that's the only difference. The syntax is very similar. The only difference is that you put the while condition at the end, and then you'll say do whatever the body is while whatever the thing is. So we won't go into that because it's not that important. Like, you rarely will need to use it. There are hacks that you can get around. Like, you can just do the thing outside of the loop and then you call your loop. This is why I keep saying that it's just syntactic sugar. They all do the same thing. All right, so now that you have this, go ahead and I guess commit and put a message, or I guess something. And I would recommend you make your messages useful. That's what these messages are for. They're meant to be helpful. You got any questions so far, Kyle? Or you're just like, you're good? Wait, is he even still here?
It's a little node bits and pieces that I don't realize. But otherwise, I understand.
Okay. Oh, you don't need to open the git log. We're good. We only did that last time because I wasn't expecting to see it. All right, so now that you've done this, are you tired of going in and typing node loop.js yet? If you're not, I'll let you keep doing it, and then we'll get to it later. You tell me.
A little bit, but then I can just do the arrow key to grab it. I mean, unless we change the command.
I mean, well, all right. We'll wait till you're tired of doing it. Let's go ahead and create a new loop. So just comment out everything. Command A space and then command arrow or slash, whatever that thing is. The one to left of your left shift key, right shift key. I'm sorry.
Man.
You're selecting everything and then commenting everything.
Wait. Not. Oh, there you go. Oops. Yeah.
All right, so we're going to emulate our first while loop, the infinite loop. So the way we're going to do that is you're going to do for. This is now the for loop. We're getting into that. And then parentheses. And inside of the parentheses, do 2 semicolons. All right, now you're going to put a body after your parentheses. So that's going to be the curly braces. And throw in your console log. Hello.
Wait.
You got to put something in there. Doesn't really matter what, just put something. All right, that's good enough. So let's save it and then run it again. All right, so we get an infinite loop. So the while loop and this for right here, equivalent. There's no difference.
Wow.
Now, you notice that with the while loop, that if you wanted to have some type of state that you're incrementing, you have to do it in 2 different places. You have to first define a variable on line 2, and then you have to increment it on line 4. A for loop gives you a way to define all of those things in one place. So you can define your variable first. So let's on line 23 inside of that parenthesis, let's define a variable. We define variables using 1 keyword. Yes. Call it something. It doesn't really matter. Just call it something. And then you have to give it a value. So you have to set it to like, what is it supposed to be? So you could put any number you want.
Yes.
Okay. And then the second thing, this is the same thing that's in your while loop on line 3. This is the condition, which is when should it exit? And this has to evaluate to a Boolean value. So it's a Boolean expression that's accepted here. Which, if you remember, because certain numbers are falsy and truthy, technically you could just put a number there. But we're not going to do that. All right, and then the final thing that you have to put after that semicolon is the incrementer. So how much do you want to increment by? So in this one, I don't think you can do actually no, you can do a pre and a post here too. But for now, let's do the one that I'm going to recommend you do from here on out. Don't do plus plus, don't do plus plus A or A plus plus. Instead, do the assignment operator, like the assignment addition operator. So that's going to be plus equal. So there's a whole, like there's plus equal, divide equal, minus equal, times equal, caret equal, like all of that. So we're going to assign, which I think is better because, well, first it's very clear the order that things are going to happen. I think that it's a little confusing for newcomers. You know, this plus plus x or x plus plus, as you may have noticed. So put a value, it doesn't really matter what. You can increment by however much you like. By the way, plus plus only allows you to increment or decrement 1. That's why it's a shorthand. It's just like incrementing by 1 is such a common thing that it's just plus plus. All right, so we're going to do that, and yeah, go ahead and run it. Before you run it, what do you think is going to happen?
It would print hello for, let's see, 4 times.
Okay, let's see.
Yeah.
All right, hold on. All right, give me a second. My music is starting to piss me off now. It's like it keeps doing this weird glitchy skippy thing.
Oh, I can't even hear it.
Well, you can't hear it, but it's on stream.
Oh, okay.
All right. Hopefully it will not continue whatever it's doing anymore. Okay, so let's explain. Why is it 5 and not 4 like you thought? Before I even explain, have you ever heard of this class of errors called an off by 1 error?
No?
No? Well, this is one of the most common types of errors. It's off by 1. They result in all kinds of things. The most common of which is array out of bounds indexing error, where you're like trying to access memory that technically you don't have access to. And honestly, this is how you can create seg faults, which don't exist in JavaScript land, but this is absolutely a thing in the OS because, you know, it's not really managing your memory. It's you going to a specific block of memory that your program doesn't have access to, and it causes it to crash. This is also how this is what most exploits are based on, which is you find some way to like get a program to crash so that it goes to a piece of code and memory that you control, and they can go and execute arbitrary code. Anyway, so why did this give you 5? Well, we're going to trace through it just like we did last time. So go ahead and copy, or I guess don't copy, just put a comment, and we're going to start off with a equals 3. Or just, we're going to say 3 is, no, just 3 less than equal to 7. And that's the key right there, but we'll get into that soon. So is 3 less than or equal to 7?
Oh, wait, sorry. It's not even 7. True.
All right, so we're not even going to worry about the increment right now because we're going to pretend that you get that. So let's go on to the next one. It's 4 less than or equal to 7.
Yeah. Yes.
All right, what about 5?
Yes.
What about 6? All right, so you're at 4, so this should be setting off alarm bells. So is 7 less than or equal to 7?
Yes.
That's why you get 5. It's
Gotcha.
because you have it's including 7.
Okay.
And I'm dead ass, like off by 1 errors are one of the most common types of errors. It's a logical error, so they're harder to find. Stuff like syntax errors, the compiler or your editor will tell you that. But runtime errors are a little bit harder. But logical errors are a class of runtime errors, and those are even harder because it's just the logic is wrong. Which, how do you know that? You have to go and think about it. All right, so let's say that we wanted to make it so that it was only 4 like you thought it would be. Remove that less than or equal to, just make it less than or whatever the thing is, and then you'll get your value that you expected. All right, making sense so far? Okay, a little bit. Okay. All right, so we're going to ignore that. Like, we're going to keep the hello. We don't need to change it. Go ahead and make a commit and just say this is your for loop. Just click cancel. You know what? Let's go ahead and get it. Let's configure Git right quick. So if you go to your Git log, just copy what it's telling you, so you don't have to type it yourself. So go to so the right window. Actually, you know what? I think I can point on your screen. Give me a second. So go to this right here. Oh wait. I'm sorry. I think it's output here. Go to that. Yeah. I gotta figure out how to. Oh. I don't know how to clear whatever I put. Oh, I found it. There we go. We'll do that. Oops, shit. Why did I do that? Annotate. There. Okay. Okay. All right. You see that where it says like git config? Here, let me draw on it here. Well, not that one. I'm sorry. This one right here. My bad. That one. So copy those 2 lines and put it over here in your text editor for now on the left side. And then open up your terminal again, which is control tilde. After you paste, you got to paste those values in your text editor, like I said.
Oh.
All right, so in your terminal, copy the first line, but make sure you put your email in there first. And you'll do the same thing for your name afterwards. It's command shift left arrow to get to the beginning of a line.
Oh, nice.
All right, now you can go ahead and delete whatever that is that you have on line 31, 32. And we're going to motivate the reasoning behind the next type of loop we're about to get into. So in order to motivate it, I need you to create an array on line 22. An array is going to be square braces. You got to give it a name too. So like it's a variable, name is something. It doesn't matter what. Just give it a name. Just type a character on your keyboard. Yeah, there we are. All right, cool. So we now have an array. And one of the nice things about loops is that they expose the value that we've defined on line 24. So A. We have access to A inside the body of that loop. So go ahead inside of on line 26, change hello to A, and you'll see that it'll do the same thing that it did on the while loop. No. Hello is yeah, there you go. Yeah. You gotta save it and run it. All right, so this is one of the Okay, so now that we have that that value a, the way that we access values inside of an array is using we index into it, and the way you index into an array is you the value, which is I. So go ahead and put I inside of your console log, whatever thing.
Just inside of it.
Yeah. And then delete the A, and let's see what it's going to print out when you print out an array. So go ahead and run that. All right, so you get back an array. Well, it's showing you the literal. So that's what you're seeing here is called an array literal. And it's called an array literal because we're using like symbols to represent it versus like a name, which would be array. So now that we know that we have the array, let's index into the array. The way that you index into an array is with square braces or brackets, and you give it an index. So go ahead and put square braces after your I and give it the index. So you can put whatever you want here. You could put 0 or you could put A. I would recommend you put A because that's the thing that's in our loop that's that's going up. All right, run that. And before you run it, what do you think is going to happen?
It will it'll start to put these numbers into the array.
All right, well, let's see.
I think I saved it. Okay. Oh, it's undefined?
Yes, it's undefined because there is no value. You just have an array. There's nothing there. So if you try to get the second value, what's the second value?
Oh.
You don't know, do you? Neither does JavaScript because it's not there. So the default value for emptiness or nothing is undefined. So if you want to make this defined, put some values inside of your array. So you can put strings, numbers, booleans, objects. You can put whatever you want, really. You can even put other arrays if you want.
Yep.
All right, go ahead and run that and see what happens.
Oh.
I think you'll get the point with just one.
Yeah, because there's no third object in there.
Exactly. So what can you change to get green to show up? There's one thing you can change, just one thing.
This to 1? Or I could change this 3 to 1?
Try it.
And
you think it's going to?
Well, actually, green, right? It would probably start at 0.
Well, let's see. Well, let's see. All right, so here's lesson 2, I guess. Everything arrays in JavaScript are 0 indexed. So if you want the first element, it's 0. If you want the second one, it's 1. Now that may seem confusing, but I think that's only confusing if you don't really get how memory's working. This index is technically not saying give me the first item. What it's saying is offset by a certain amount. So when you start an array, that's the memory address. Like you're at the address for that RAM, and then you want the first value. Well, it's whatever the value is at that address, and then we go to 1, which is an offset of 1 to the next thing, which is why it's 2. So it's not really saying give me the first item. It's really just saying this is how much I want you to offset from the home address for this area of memory, because that's what an array is. It's just a contiguous block of memory. So well, maybe not in JavaScript, maybe because this is an object, but your operating system, this is how it represents arrays. It's literally a contiguous block of RAM, and it's addressed. The address size is based off of the data type that's in the array. But of course, we don't have data types in JavaScript. So this is like if you're in like C land, you would have to know the size of the values that you're putting in. This is why knowing stuff like integer, int 16, int 32 big int, or string or whatever, this is why that's so important. It's because if you're going to use an array, you got to understand, well, when I do this offset, how many bytes do I need to offset by so I get to the next value? So I can read it in. All right, so you good so far with this?
Yes.
Yo, what's up, casual economists? You know, I mean, you're not really that late. Oh, there's no lateness. I don't plan these, so don't feel like you have to be here at a certain time. All right, so now that we understand that arrays are 0 index, let's fix this so that we get green. All right, cool. I think this is a sufficiently motivated example for why we have the next loop. So, well, actually not yet. We're gonna go a little bit further. So right now we see that we're getting green, undefined, undefined, undefined. Well, that's because we've hard coded the end condition, that a less than 7. So what we could do is we can say, you know what? Maybe I only want to go until we get to the end of the array. And fortunately, arrays in JavaScript, at least, they have a function on them called length. Or is it a property? It might be a property called length, which returns to you the size of the array, which is the number of elements in the array, even though it's technically not true, but the number of elements in the array. So what I want you to do is on line 25, change your Boolean expression. Remember, that's the one in the middle. Change that such that it's not 7, but it's the length of the array. Well, you still need to, it still needs to be a Boolean expression. You can't change that part.
So
your array is not called a.
Oh, that's right.
All right, yeah, go ahead and save it. All right, so now it only gives you the size of the array. Now, you can imagine that, like, all right, well, this is error prone, right? Like, what happens if the person's like, you know what, let's do less than or equal to. Go ahead and put less than or equal to. What's going to happen? In JavaScript, it's technically not going to crash because it's JavaScript, but in better languages, it'll crash. So let's try this out and see what happens. Oh, no, what do you think's going to, oh, never mind.
Oh, sorry.
You get undefined.
Yeah.
Right, so because this like is error prone, there's another looping structure. I think I don't know, it uses iterators. It's enumeration, right? So let's go on line 33 and we're gonna show how to do that. And it's going to be kind of similar. So we're going to say for, and then space paren, yeah, and then inside of here you're going to say, let's use const, because I want to drive home the point that this is a value that can't be changed as a read-only variable. I know that's a misnomer, but that's what they call it in JavaScript land. It's technically not a true constant, so that's why I go along with it. All right, so you can call this A if you want, or B or C. All right, and say of for OnlyFans. Okay, and now you'll say your array, which is I. All right, and then after that, exit your parens and then put curly braces.
What?
Curly braces.
Oh.
And then console log A. And before you run this, you'll need to comment out 23 through 27. I'm sorry, 25 through 27. You still want I. So notice you get the same result as you did with the for all that other crap. So this right here is also syntactic sugar, but this is such a common pattern in programming. Like, this is why it's here. So it's doing a few things for you. Number one is, do you care how many things are in that array? Did you even ask? On line 34, is it any of your concern at this point?
Mm, no.
Well, yeah, no. I mean, if it were, you would see dot length, and you don't. So you
Um,
no longer have to care about if there's an element or anything in there. It doesn't matter. You also no longer have to index into the thing. So you'll notice that on line 26 how you had to index into the array,
right.
give it in the offset. Another thing is there's no possibility of an off by one error because now you're not writing that condition. You're also not worried about incrementing the value, and you're also not worried about like assigning, like having an initial condition. It's literally just like, here's my thing, and it automatically gives you back a value that you can use, which is a. All right, so this is hopefully that's a strong motivating example of like what for is. So hopefully I don't have to explain it any further, but if I do, we can. Do you understand it? And this goes for you too, Kyle. I know you're here. Like, it's all right.
Wait, actually, how come you just have to put a in the console log for it to instead of the index?
Well, that's what this for const of does for you. The for of
Oh,
loop, that's actually the point of it, is that you no longer have to worry about that. It's doing that for you. It's abstracting it for you.
oh,
It's syntactic sugar. So now instead of you having to worry about, oh, I have to first create a base condition, or not a base condition. I need to set my variable first, and then I need to have my condition, and then I need to have like an incrementer. Oh, and by the way, I also have to have the array somewhere, and then I also have to index into it to get the value out. This just does that for you. It's removing a whole
right.
class of errors. There's no way that you're going to get an off by one error in here. There's no way that you're going to access memory that you don't have access to, aka get undefined, unless, well, actually, delete the green and see what happens. And this should make it clear too. So go ahead and run it. Before you run it, what do you think is going to happen?
Would it not run? Because it's empty.
Oh, try it. Let's see. Does that answer your question? So there's no way that you're going to get undefined because it's based off of whether or not there's values in it, which is really cool because, you know, like maybe you don't know how many values are in an array. That's
Right.
kind of common, right? Like maybe you've loaded some data from an API and it's like you don't know what you're going to get back. Well, since you don't know what you're going to get back, using this is awesome because now you don't have to ask, all right, well, how many things are in there? And then you don't have to worry about, did I use the right one? Am I going to get off by one? Like, you don't have to worry about it. However, I guess the bad part about this is that maybe you don't want all of the things. That's why I call this an enumerator. Like it enumerates across your array, right? So generally it's going to go from the beginning of the array to the end. There is a way to get it to not do that, but that's adding additional logic, which, you know, and actually we're going to get into that shortly about how you end the loop, because maybe you don't want the loop to continue, or maybe I don't know, we'll get into that soon. Let's talk about the other type of loop. So go ahead and I guess do a commit, and this is a for of loop. And if you want to learn more, you'll MDN and for of. You didn't save it. You have to stage changes. I'm talking about in Git. You have to stage it by clicking the plus button first.
I have to.
I have to click the plus button. You have to stage things before you can commit it.
Oh, wait. Hold on.
Now you can write your message. All right, if my window fucking leaves my screen again, I'm gonna go crazy. It's starting to piss me off now. Oops, sorry. My bad. Okay. Well, yeah, go ahead and commit. Like. All right, so this next loop, go ahead and comment out 34 through 36. We're not using that anymore. All right, this next loop is called a for in loop. So we're going to do the same structure as 34. We're going to just say for const a, if you want, of, or I'm sorry, not of, in I.
And
just copy what you have on 34. Just literally type that and then replace of with in. And console log A. And before you run it, what do you think is going to happen?
Wait, there's would it throw an error because it doesn't know what A is? Wait, no, you're declaring.
Well, you're declaring A.
Yeah. Okay. A in.
Here's a hint. Go up to line 23. Is there anything in there?
No.
Is the structure of 38 very similar to 34?
Yes.
What happened when on line 34 you had an empty array?
Nothing returned.
Nothing happens because there's nothing to do. It's the same here. This is also an enumeration type of loop construct.
Oh.
So nothing will happen. It was kind of a trick question. I know you're like thinking because it's a new thing, a new keyword in. No, there's nothing there, so nothing will happen. So if we want something to happen, put a value here. Just put 1. It doesn't really matter. Just put 1. All right. Now save it and run it and see what happens. You get back 0. So based off of what you just got back, what do you think is happening?
Is returning the index?
Yes, exactly. So for in gives you the index, for of gives you the value. There are certain times where you want the index and there are other times where you want the value. So yeah.
Gotcha.
All right, so that's it. Like that's really it with the for in. Just know that it exists. It's the same as of, except you get the value, or not the value, the whatever you call it.
Yep.
Now there's another one that we can do, and at least I think you can do it. Yeah, actually no, there is another loop that we're going to do. So go ahead and make your commit, and then we'll talk about another kind of loop that kind of merges for of and for in it's more of a functional type of thing. Whereas I think that 39 is, I mean, it's technically not declarative, but it's more declarative. Remember, you have to stage before you can commit. Anyway, so let's go ahead and comment out 39. We're done with that. Okay, so now we're going to get into array methods. And for this, what I want you to do is open up Arc and go to MDN. The reason why I'm having you do this is I also want you to get familiar with using the docs. So we're going to do MDN and then space and then for each.
Space.
For each. All one word. Yeah, there you go. And go ahead and click that on that prototype. So the reason why we're able to use this is because remember 23i is an array. Arrays in JavaScript are objects, and if you want to test this, actually we're going to test this. Go on line. I mean, at this point, you can delete all your comments. We don't need the comments anymore. These are all committed, so if you want to go back, you can always get it. All right, so let's declare a variable that holds an array, and let's make this a const because we don't want to reassign this. So let's name it better now. Let's call it ARR or something like that for array. All right, cool. Now we have an array. It doesn't have anything in it, but that's okay. We'll leave it empty for now. On line 2, go ahead and do ARR dot for each. No space. No space. You have a space, no space. It's dot for each. You see it? It's the second to last. Yeah, there you are.
Oh, it needs to be.
All right, cool. This is a function. And the reason why you're able to do this dot is because we won't get into this now, but maybe in the future, if it becomes important, we will. JavaScript is a prototype, like a prototypal object-oriented language, meaning that if you want to extend an object with functions, you add it to the object's prototype. And whenever you do dot, what it's going to do is it's going to search the prototype for that function name. So in this case, when it's saying like go into the prototyping graph for each. So if you go back to the MDN docs, and this is important, you'll notice that it says array.prototype.for each. All right, you see there where it says prototype? So all of the functions are going to say prototype, but in your code, it's not going to say that. So it's important that you understand that prototype means that it exists on the object. You can call dot. That's another way of saying it.
Exists on the object. So if the array is empty, then is prototype just...
It doesn't matter if the array is empty, because an array is an array. Like it has nothing to do with what's in it. It's everything to do with the value, the type of it. And let's play with this inside of your browser, because this will be easier to test out. In your browser, do Control D.
Control D.
And then do Command Option J.
Command Option J.
All right, and then you're in your console. So go ahead and do Command K. I think is how you can clear things, maybe. And if that doesn't work, then it does. All right, perfect. All right, so do define an array. So let's just say let A equal array literal, like use the array literal syntax. All right, enter. Now do A dot prototype. Proto. No, it was the underscore proto. It was underscore proto.
Yeah, I'm spelling this.
Just delete all of that and then do A dot and then select the thing that has underscore. Proto. And press enter. And open it up. That's what I mean. It doesn't matter if there's any values in it, because it's an array object. And I'm saying the word object because it is an object. In fact, let's verify that. Do type of and then space A. And you get back object. So yeah, pretty almost every yeah. I'm gonna say this might be technically wrong, but it's 99.9999% right, unless you get into like minutia details. Everything in JavaScript is an object, including undefined and null. These are all objects. All right, so with the proto, this is what I was saying, how when you do the dot, what's happening in the runtime is JavaScript is saying, all right, let me find this function, and the first place it's going to go to is this prototype, which is the underscore proto property. All right, so yeah, there you are. So now that we understand that, we can go back over to our code, and we're going to play around with this for each. function. Now the interesting thing about for each, press Command B. You can, to get a little bit more room.
Command
B.
Oh.
B as in black. We're not making anything, casual economists. We're not making anything. We're just teaching right now. All right, cool. So with for each is a function, and this is a very special type of function. It accepts something called a callback. A callback is a fancy way of saying it accepts a function that is called. So if you have a function, let's call it f, and you say the first parameter, you have to give me a function. And let's call that parameter b. Well, if you supply me b, it's not technically a callback yet. This may be pedantic, but these words matter. It's not a callback unless you call it within that function. So for it to be a callback, it must be called. So that should be a hint here, so that whatever function you pass into this for each is going to be called. And because this is a for each, it's an iteration method, it's going to be called for every element in the array. So if you have no elements in the array, it won't be called. So let's go ahead and let's give this a function. So let's parentheses, and we're going to give it a function. All right, and then for now, we're just going to do console log. And I'll explain to you why we're able to do this in a second. No. Just console log, yeah, just like that. And enter, or save it. And I guess before we do this, what do you think is going to happen? Start with what you know. You've just typed console log, so what do you think that's going to do? What does it generally do?
It prints something?
Yeah, it prints something, yes. All right. Is there anything to print?
No.
So what do you think this is going to do?
Nothing?
It's going to print nothing. So go ahead and let's verify. Let's see if I'm full of shit. All right, look at that. I'm not full of shit. All right. So let's put in a value in the array. It doesn't matter what you put, just put a value. All right, let's save and run it. And before you run it, actually, what do you think you're going to get back?
It'll print out 23.
Go ahead and run it. Notice that you get back a little bit more than 23.
Right.
What'd you get?
I'm guessing the index of it, and then also how it looks like in the array.
Yes. So here's the next lesson about callbacks. It's the function definer, aka, so let's say you created your function of f, and you say you need to give me a callback. Well, it's up to you, the person who's defining the parameters that your function is going to receive, to say, all right, your callback needs to accept these parameters. So let's bring it to here. The for each function accepts a callback that accepts up to 2 parameters.
Oh.
You can give it the value or the index, or you can give it nothing. You don't have to take the parameters. And this is one of the interesting things about JavaScript, is that it doesn't really matter. And in fact, that's what we're doing here. You're calling console log. Notice that you didn't use parentheses. You just say, all right, call this function, and what it's going to do is all the arguments that are passed to the function is going to print. That's why you got back 23,023. Add another number inside of your array, and watch what happens. And the thing that I want you to pay attention to is the thing that's in the brackets. So yeah, go ahead and run that and see what you get. Notice that the thing in the brackets remain the same. It's 23,3. So that should tell you that this the for each on every callback is giving you 3 parameters. First parameter is the value. Second parameter is the index. Third parameter is the array itself.
Oh.
And the reason why you're seeing all of it is because by default, when you pass a function as a callback, it'll just print all args. Because args are an array in JavaScript. We'll get into that. We'll get into that at some point. So let's make this so that it doesn't print everything. Maybe we only want to print the value. We want to make it behave like for of in this case. And then we're going to make it behave like for in. And then I'm going to show you why for each is this like a combination of the two. So let's make this a for of first. So in order to do that, we're going to define a callback. We've given it a function, but now we want to define our own. So there's an easy way of doing that. There's two ways you can do that actually. Well, technically there are three. We'll go over all three, but we'll start with the easiest. The easiest is to, inside of your parentheses before that console, you're going to define a function. So just say function. And then space parentheses. And then, no, you had it right. And then you're going to do curly braces to wrap your console log.
Oh.
Okay. All right. Now, before we go any further, save this and run it. And I don't want you to think about what's going to happen. I want you to explain what happens after you run it.
Nothing came back because there's no function yet?
No, there is a function.
Oh.
So you've defined your own function, which is console, which is it's an anonymous function for what it's worth. You can give it a name if you want, but what you've defined is an anonymous function. And when you call console log inside of your anonymous function, what do you pass? Like, there's nothing being passed to it because like this isn't being called as a function. You're calling it as a function. Does that make sense?
Oh.
So in the first case, because there were no parentheses, for each passed all of the arguments to console log. In this case, you've defined your own function, which doesn't take any arguments. And when you call console log, well, you're not logging with anything, so it's not going to print anything. Let's clear it up a little bit. Let's pass a parameter inside of the function parentheses. Let's call it v for value. All right, now run it again. Or before you run it, what do you think is going to happen?
Nothing would happen, right?
Yeah, let's see. Why does nothing happen?
Because passing v in it is there's nothing assigned to v.
It's a little bit further than that.
Huh?
It's your console log. You're not logging anything. You're just calling console log. There's nothing to log because there's not, like, when you call a function like this, I'm sorry, when you've defined a function and it's not being called, so like there's nothing being passed to console log. So if you want to pass something there, you have to do it yourself. So if you do parentheses parentheses v, you may get back what you may think. So go ahead and put parentheses v after your log. Yeah, there you are.
Oh.
So now we have for of. All right, so I want you to kind of let's restructure this function a little bit. Let's on the console right after that curly brace, put a new line. No, after console or right before console.
Oh.
No. before console. Yeah, there you go. And then after the parenthesis v, or v parenthesis. All right, so this right here is your function that's being called. That's your callback. And because this function can take up to 3 parameters, you can put up to 3 parameters in your function definition here. But you've only put 1, which is why you're only getting the value. Let's get the index too. So how do you think you could do that? Say what you're thinking, because we're on stream. I can't just be sitting here in silence.
Would I just add another console log?
You could do that, but that wouldn't actually help you, would it?
Oh, would I do add another like comma something here?
Now notice that you're getting back this IntelliSense here. It's telling you the first thing is a value, the second thing is the index, and the third thing is the array.
Oh, okay.
Yeah, you can call it X. And if you were to run this as is, you would get the same result.
Right.
And why do you think you get the same result?
Because the console log only has the first.
Exactly. So go ahead and pass in X. And if you run that, then you should get back both the key, or not the keys, the value as well as the index. And notice that you don't get that array. But let's say you want that array. Go ahead and print that in there. All right, so now we're back to where we started. So let's say, for instance, that you know you want all the things and you really don't care, like to do this whole define a function and all that. You just give the function that you want it to call and it'll pass it for you. So what you're seeing here is what was happening in the background when you just said console log. It's actually giving you just all 3 of the values because you didn't specify which one, so it gives you all. Whereas if you want to pick and choose, you could just find your own callback, and then you have your function accept the things that matters. And it's an array it's actually an array. I want to show that actually. So let's comment out, well, I guess before you comment, maybe you want to commit, and then you'll comment it out. I'm gonna go grab something to drink. I'll be right back.
This?
All right, ready to continue? Are you good?
Yes.
All right. I'm sorry, what were we doing? I forgot.
So.
Oh wait, I remember. All right, so comment out lines 2 through 4.
Oops.
And let's create a new function. So we'll say function, name doesn't matter.
Yes.
You have to give it a name. You have to give the function a name. It's the function keyword name parameters.
Name?
But you can't call it name. You have to gotta call it.
How
about my function. How about that? I would advise you to not get too hung up on naming. It's the waste of time because you could always change it. Like names are really easy to change. It's functionality that's more important. All right. You put parentheses, or not your parentheses, curly braces. You also need the parentheses.
Oh.
It's the same. So you see the function just above? Like, that's how you define functions. So your function VXA, it's always the same, except you can do an anonymous function as a callback, but this isn't a callback. Although technically you can create an anonymous function, but we'll get into that some other time. All right, so go ahead and put like a line. Like, let's go ahead and do that. And console log, and then put arguments. The word arguments. All right, and call your function after, like, call your function. To call a function is to like when you did the for each, that's a function call. Don't call it inside your function. Call it outside of your function. No, it's just the function name. And no dot.
Oh, there's no dots.
Well, no, because there's no prototype here. You've defined the function. The last thing was an array. You can't treat a function like an array. Okay, delete for each. All right, and look on line 2. You see where it says function? And you have those parentheses?
Oh, this goes inside the for each?
No, you're going to use parentheses. That's how you call functions. We have another example of that on line 3. There's a log, and then you see parentheses. That's how you call functions.
Oh.
All right, so save it and run it. You get back arguments. There's nothing there. So let's pass an argument. Oh, and this is also an important distinction to make. I'm sure you've heard people refer to things like when dealing with functions as arguments or parameters. There is a difference. An argument is what you pass. A parameter is what you define. So if you ever hear me say your function parameter, your mind should immediately go to your definition of the function. Whereas if I'm talking about arguments, it should immediately go to you calling a function. Like, what are you passing? So you pass arguments to a function, which is why we even have like a keyword for it. So that should tell you it's really important to understand the difference. So go ahead and pass some arguments to your function. Line 10. It doesn't matter. Just
is
type,
that just anything?
Just type something. It doesn't matter. Is that what you're typing? That should be a string then. Put a quote around it if you're going to use S. All right, now let's run it and see what happens. So notice what you get. You get an object of key value pairs. Except the keys are numbers. There's another thing where the key is a number. It's called, what do you think it's called? Just look up at the top of your file.
An array?
Yes. So notice how you passed in a value into this function. However, you didn't define any parameters for your function. Notice that? No? Maybe?
Oh, that would be this, right?
Yeah.
Or whatever's in. What
Yeah.
do you hear?
So you passed in an argument despite there not being a parameter. Welcome to JavaScript. You can do this. You can do that just fine. Now, arguments is it's a keyword. It grabs everything that was passed to the function. So what this should be implying is that you can optionally have parameters, and we've just discovered that when you pass a callback to that for each. And I kept saying that, well, because you didn't give it any parameters, and like it's just going to do all of it, because that's what console log does. It prints whatever you give it. Well, it's given arguments. We see what arguments is. It's actually a value. It's just that it's hidden from you. So let's say that you wanted to get access to the first argument in your function. Well, what you could do is you can define it inside of on line 6 as a parameter. So let's define it. Just give it a name.
Okay.
All right, and then log a instead of arguments. And you get back the value s.
Right.
All right, so what you've done is you've given a name that you can access inside of the body of your function by specifying the parameter. Now, you don't have to specify this. Like, you could get it from the arguments object / array yourself. However, that could be a little bit not great, because it's not communicating to the users like, what am I supposed to pass it? But this should also be an indicator that you can pass more stuff than what's defined. And if you're like smart about it, you can say, all right, well, I'm going to design my function so that it accepts these things. However, I'm also going to be able to pass these other things that can do some other hidden things that I may not want other people to know about. Right, so that's kind of why you were able to do your console log without doing like passing things to it. So every function has arguments. Even when you don't pass any, it's always going to have arguments. And this is just part of how JavaScript works. All right, so now we've done the for in and the for of using for each. You've learned that for each takes a callback. A callback is simply a function that gets called. And we define 2 ways to give it a callback. You can just give it the function that you want to call, or you could define the function inline anonymously, which is what we've just done here. You can also give it a named function, which is what you did the first time, console.log. That is a named function. Whereas an anonymous function is one that doesn't have a name. So like, to drive home the point, what's the name of the function that you gave in line 2? You see it?
There is no name, right?
Exactly. That's what makes it anonymous. So that's what makes it anonymous, is that it has no name. So let's show how to define another type of anonymous function. These came from C#, which themselves came from another language, but we won't get into it that much. This is going to be, they were called lambda expressions in C#. In JavaScript land, they have a stupid name in my opinion. They call it fat arrow functions. So the way you define a fat arrow function is, let's first uncomment out line 2 through 4, and we're going to do it there. All right, so delete function. All right, and then after the parentheses, do equal greater than. The second set of parentheses, yeah, right there.
Equal greater than.
Or the other greater than. Less.
Oh, no. Oops.
All right, this is another way to create an anonymous function. This is a fat arrow function or lambda expression, and they do behave slightly differently. We don't have to go into that right now though. All right, go ahead and save it and run it, and you'll see that it does the same thing.
Do I need to comment these out?
Yeah, you could, yeah, honestly, you could delete that. This was purely to show you why you were able to do console log and not specify arguments. It's because they're passed, whether you want them passed or not.
Read the comment out. Okay.
So you get the same result. Now, what's cool about this is that, let's say you are either returning just one thing or you're given an expression. You don't have to have the curly braces if it's just a single expression. So what you could do is delete the curly brace after the, yeah, you could delete both of those, yeah. And you can put it all on one line. And run that and see what you get. Same thing. All right, now we can do one more, because all we're doing is printing the value, the index, and the array itself. So let's delete the parentheses and the fat arrow. The parentheses too.
These?
Yeah, and the XVA, delete all of that. And then also there's no XVA or V, so you got to delete that over there too. And now, because you really don't want to call console log with nothing, so let's delete those parentheses too. So now for each is going to pass arguments. So go ahead and save it, and we're back to where we started. So you got to see how to expand it out using the full function. Go ahead and run it, and you'll get back the same thing. So we went from like console log, which you're like, okay, I don't understand how that's happening, to all right, let's build out the entire function anonymously, to let's turn it into a fat arrow function, to oh, there's syntax here, so now if there's only one line, you only have to do one thing, like you don't have to do the curly braces. And oh, by the way, we can delete the other stuff too, so we're back to where we are. So now you should understand that like we can do all of these. You can also create a named function using fat arrow syntax. So let's show how to do that right quick. On line 9, we're going to make a constant. We'll call it fat arrow, const fat arrow. No, like the word fat arrow. You have to give it a name. And then this is going to be equal, so you're going to assign. So this is the assignment operator. And we're going to give it a fat arrow function. So you give it parentheses, and then the fat arrow thing. I'm going to have to stop saying that because it sounds dumb to me. You're going to do equal, greater than, and then something. Let's just log. I'm a fat arrow function.
Did you say log it?
Yeah, like console log.
Oh.
So console is an object, which is why I'm not saying console log, like it's like we're logging it. That's the function that we're calling. It just so happens to be on the console object. How do we know it's an object? Well, you're doing dot. If you do dot and you get things that you can call, it's an object.
Okay.
All right, now give it a value. Print fat arrow function. You have to give it that as a string. You can't print the function in itself. All right, so what you notice is now you have a function called fat arrow. So you can call it like any other function because it is a function. This is I guess another lesson is that JavaScript is a functional programming language, meaning that it support. Okay. Meaning that functions are first-class citizens. What does that mean? It means that you can work with functions as you can work with any other primitive value. They are primitive values. That means that you can pass them around to other objects, or I'm sorry, not other functions. You can call them. You can. I mean, that's really there's more, but that's all that matters. Is that it's a function. So now you see that there are 3 ways to create a function. Hopefully, there's using the function keyword, which if you don't give it a name, the name is optional. Then it's an anonymous function. If you give it a name, it's a named function. You also have a way where you can assign a function to a variable. Notice that the type of function that you're assigning is an anonymous function. Notice that you don't have a name for that function. You're assigning an anonymous function to a constant, thereby giving it a name.
It's like, so if over here, if I wanted to give it a name, whoops.
You can't.
Oh, I can't?
No, I mean, you are giving it a name. You're giving it the name fat arrow, which is you're assigning that anonymous function to that variable. And the reason why this is important to note is that these lambda expressions, they're always anonymous. So if you want to give them a name, you have to assign it to a constant.
Okay.
All right, so yeah, that's it for that one. And honestly, I think that's it for loops, or at least for this kind of loop. There are other loops. In fact, you're looking at them in your array functions over there. Pretty much every one of these functions are looping functions. And what I mean by that is that they leverage loops to do things on your behalf. So let's say concat. Well, concatenation, as far as I think it's going to take all of the values in an array and stick them together using some type of separator of some sort. Or it may not even be, I think that's join. I think it just adds them all together. In fact, let's see. Call array.concat. You have to call it. All right, now let's print the result of concat, which that's logging it.
Like that, right?
Let's run it. And if that doesn't work, we're going to look at the doc, because I actually never used this function. It does what I thought. Okay. Or no, does it do what I thought? Yes. No. Yes, maybe. All right, let's look at the docs. Let's see what concat does. Let's see if it accepts a callback. They're in alphabetical order.
Oh, I see it. Wait.
Oh, I see. Okay, so it's concatenated with another array. Okay. So inside of concat, give it an array, literal, and just put like 1 or something in there. And this should add them together. No, you have to give it an array.
Oh.
So you should be thinking like, how could it add these 2 values? Like, you have 2 distinct arrays, but you get an array with 3 things where one had 2 and one had 1. The answer is you loop through them. That's the key. You loop through them. So all of these functions are dealing with loops. Like when you think of entries, okay, that's going to get all of the values in the what do you call it, in the array. Well, how do you get all the values? You loop through it. You enumerate through it. Or let's say this every. Well, I think every takes a callback, which is a Boolean expression. It has to evaluate to a Boolean expression. So, well, how does it know which one of the things, how does it know whether or not all of the things return true? Well, it calls that function on each element in the list, and if they all result in true, then the whole thing is true. Although we really just short circuit. The second we get a false, we know that it's false, because every, right, like if you have 10 things and the second thing is false, then obviously everything isn't that, because we short circuit at that point. Every can't be true if one is false. That's really what we're getting at. So all these are all our looping things. So if you understand, I'm gonna call it enumeration. I don't really know. I think it's called enumeration. Can you Google that? Google enumeration for me. JavaScript enumeration, to make sure I'm not lying to you.
I think you're correct.
I think I am too, but I don't want to rely on me just thinking it. Oh, enumerate. Yeah, there you are. Enumeration. Not enums, but why is it saying, all right, put enumeration in quotes. Okay, so they may call it, well, yeah, oh, I see it, a JavaScript enumerator. There we are. It may be called iteration in JavaScript. It's a similar concept, but they are different. But I wouldn't trust JavaScript to get it right. We're looking for a definition of enumeration. That's what we're looking for. No code. So just like search through here in enumerator. You see it right there in the left bar where it says, oh, there you go. A basic representation of an enumerator. Hold on. Scroll down.
Yeah.
Okay, that's not it. Okay, so go back and type Wikipedia at the end, because Google gives these types of results, which is just weird. Maybe this is why people are becoming dumber, is that this is what Google gives you back. No, the second one where it says enumeration. Yeah, this is technically what it's doing. I don't understand why we can't find anything that says this. So it says enumeration is a complete ordered listing. When you did the for of, notice that it was the order that you defined it, and it was complete. Therefore, enumeration. I don't understand why we can't Google that and we get back all this crap about enums, because JavaScript doesn't have enums as far as I understand. All right, anyway, so now let's talk a little bit about, more about looping. There are some control structures that you need to know about that only pertain to loops. So, and it is all loops except for each. Kind of. We'll get into that one. All right, so let's do a while loop. And I want you to give this a like some state. So like you're gonna define a variable outside, like we did at the beginning. All right, and let's say while x is less than 5. Let's double it. Let's say 2 times 5 or 10. And let's set x to 0. Well, let's just make it 10. We don't want to have other people do math. 2 times 5, we can do that, hopefully, right? 2 times 5.
Oh, I can't do this?
You can, but we know what the answer is, so why would you hard code it? We could just, I don't know, it's just like, why have the computer do extra work when you know the answer? It's like you could put 1 times 1 times 1 times 1 times 0, but we know it's 0, so what, you just do 0, right? Or I don't know, maybe that's just what I would do. All right, so we have this thing here. Let's do a console log with the x++ like we had before. And run that, and you should get back what you expect. Well, what do you expect first? I don't know what you expect. What do you expect to get back?
The
last
0,
number. The last number. What do you think the last number will be?
9.
Okay. Let's run it. All right, cool. So now that we have this, we're now going to do something. We're going to use another operator. This is the modulus operator. It's not that important that you understand what it does, but the modulus operator returns the remainder. So you know in division how you have the actual, is it the quotient? Is that it? No, it's not the quotient. What's the actual thing that you get back? What's that called? I forgot. It's been like 30 years. Whatever that is, you're going to get back that first thing, and the second thing is the remainder. Modulus is going to give you the remainder. So what I want you to do is throw a if condition in here on line 15, and you're going to say if x mod 2, if it's equal to 0, then we're going to call a very special keyword. And it's called continue. And you don't need to put braces or curly braces. Just at the end of the parentheses, just say continue. The word continue.
Oh, continue.
All right, now save it and run it. What do you think's happening? Kyle, you're up too. What do you think is happening? Can you do command plus one time, Elizabeth?
Command plus.
And let's make your side thing smaller. Like move it over to the right a little bit.
So I'm kind of cheating. I'm doing this right now in Bash. You're essentially solving.
Well, no, that's not the question though. The question is, what do you think is happening? So she's like press Control C inside of your terminal, and then do Control L to clear everything, and then up, and then run it again. All right, what do you think is happening? This is for both of y'all too. Like, put your heads together. Y'all should talk amongst each other and not just think in your head, because that's not thinking. You gotta talk, say words.
Trying to remember what the percent sign.
Modulus. It gives you back the remainder.
The remainder of 2.
Yeah. Well, no, not the remainder of 2.
Of x. Yeah.
Yeah.
So
divided by 2. Of x divided by 2. Yeah.
That makes sense, Elizabeth?
Yeah, but I would assume that it would just skip all the like 2s that are, like the numbers that are divided by.
So earlier, I said that one of the most difficult types of errors or class of errors is a logical error. So I said one thing, but you wrote something different. Now, we can still evaluate this. What is 0 divided by 2?
0?
0.
Yep.
What's 0? Is it truthy or falsy?
False.
Okay, so we're going to go to that continue there. And we're going to continue, right? So like, we're not going to continue. It's false. And then we go here to our console log. We write 0. And then we increment it to 1.
Right.
What is 1 divided by 2?
1.
No.
No.
The answer I'm looking for is that it's not 0.
Yeah.
So remember, if a number is 0 it's falsy. If it's not 0, it's truthy.
Mm.
So 0.5 is not 0. So you're going to get to line 15 and it's going to be 1, and you're going to continue. And then you're going to get to line 15 again and it's going to be 1, and you're going to continue. And then you're going to get to line 15 again and it's going to be 1, and you're going to continue. You're going to get to line 15 again and it's going to be 1 and continue. I could keep going ad infinitum, but I don't want to. At no point are you incrementing x after the first time. So you get an infinite loop. Remember when I said that it's really important that you get that truthy falsiness? That's what I'm getting at. So now if you want this to work, what I would do is you would say if it's equal, that's what I said, like if it's equal to 0, that expression x mod 2, if that's equal, and when I say equal, I'm talking about equality, so that's triple equal. Triple equal. All right, now run that. Well, you got to first do Control C over there to stop your infinite loop. All right, now what do you think is happening?
It's always
I hear you quiet too, Kyle.
I don't like how it's handling this. Yeah.
All right, so what's happening? All right, we're gonna run through it again. We're going to get 0. 0 mod 2 is 0. We're gonna continue, and then we're gonna get to line 15. 0 mod 2 is 0, and then we're gonna continue, and then we're gonna get to line 15. 0 mod 0 is what? One of you, hopefully. Even in the chat, somebody, yes, yeah, someone in the chat too, yeah, 0. So at no point is it never not 0. So it's always going to continue, and this is the lesson with what continue does. Whenever you call it, it's going to skip all of the other stuff. So it's never incrementing at x. It's never getting to line 16 because we continue. It doesn't mean go to the next line. It means go to the next iteration of the loop. So no matter what's after that, we don't care. We just say, all right, go. So let's say that we wanted this to work the way that you would expect it to work. What you could do is move that on line 16, turn the x plus, change that to just x. And then on line 15, where it says x, do plus. Now save it and run it. Someone explain to me what's happened.
Why can you increment direct line? Because you're asking if you set 0 and then it's already incrementing. Aren't you skipping?
No. So what's important to realize is that you can give, like, whatever you put inside of the if statement is an expression. And expressions are always evaluated. So when you put this x plus, that's an expression, and it's going to get evaluated. And then it's going to do the next thing, because the mod 2 equal, that's itself an expression. So it's going to evaluate that. So what's happening is when you do this x plus, it's going to first evaluate where x is equal to 0, and then it's going to increment, so that it's basically like having a secondary variable somewhere else. It'll increment it there. So then when you come over to the next iteration of the loop, it's the value that you incremented it to.
That makes sense.
Now, maybe you don't like the x plus thing, and to be honest, I mean, I'm not that big of a fan of it either. But this is one of the cases where this is what you want to do if you wanted to do this kind of thing. There's another way you can accomplish the same thing. You can invert your logic so that you can then get your your incrementer outside of that conditional. And inverting your logic means changing that first equal sign to a not equal. And then, you can do your x plus plus before that or after that. But in every case, you probably want to increment the value first because you need to make sure you're changing that value. And I think this is another like motivating example of why for loops can be useful. Because a for loop is going to happen anyways. You don't have to worry about it. Whereas with this while loop, you have to really think about the control flow of how this loop is working and making sure that you increment the thing. So if you're wondering like, why do we have all these different types of loops? Well, this is why, because certain things could be a little bit more challenging if you have to manage it yourself. So let's change this into a for loop, and we're going to keep that same kind of logic where it's like the if whatever the thing is, then continue. And what you should notice is that it works the way that you expect. So just on another line, do that. So keep that as plus plus, and then and then go to another line, and we're going to do a for. Like outside of your loop, it needs to be outside of your loop.
Am I just writing another version of this?
You're just writing a for loop. If you're curious what a for loop looks like, go to MDN and type in MDN for loop. Yeah, just copy that. But not copy it and paste it, like type it, because that's the only way you're going to learn is to type it manually. Remember, I want you to not use plus plus, use plus equal 1. And you can copy line 15 and 16. And we're going to make one minor change, but I want you to tell me what you think that change should be. Yeah. And there's also one other change. It's also minor.
Make this back into equal.
Right. All right. Now comment out your while loop, and then we'll get rid of that. Well, not get rid of it, but just comment it out, and then we'll rerun it. You don't get back the same result, but that's okay. Don't worry about the fact that the result looks different. What I want you to pay attention to is you didn't get into an infinite loop situation.
Right.
Because now you are no longer responsible for incrementing your incrementer, your variable. That's one thing that the for loop does for you. It doesn't really abstract it, but it controls all of that for you, so you don't have to worry about it. So in that sense, I would say, a for loop is easier, but some people think while loops are easier. I am one of those folks where I'm like, I think it's because I learned for loops first. Like literally, when I say that, I mean like, it wasn't like it was days. It was just like, we talked about loops, and I think they mentioned for loop first. This is back when I was reading in the book. I forget what the book was, but they mentioned for loop first. So for some reason, I think that's easier. But I mean, hopefully you'll agree, right? Like you're no longer having to manage your own state, your own incrementation. It's doing that for you. And then when we go a level of abstraction higher to the for of and for in, it's abstracting more stuff from you. So now you eliminate a whole class of errors. And for each is doing the same thing. All right, so this is one of the looping control structures. Continue. It just means go to the next iteration if this condition is true. So let's say, for instance, you want this to be, the thing. You would reinvert your not equal. I'm sorry, on line 20, you'll invert it to be equal to not equal, and then that should give you the thing that you expect, which would be I think 2, 4, 6, 8, maybe, or something like that. Yeah. Now you may be wondering, and maybe you're not, but for people who are watching, if y'all are wondering why it doesn't print 10, well, it's because with the while loop, we print the thing first, and then we have to go and check to see is it bigger. Whereas with the for loop, all of that's handled for us. So when it tries to do 10, it's going to be like, oh, it's not less than, so it's going to be false. So it's not going to iterate or go through the body again, because it's looking at that result first. All right, so we know continue. There's another one that's worth knowing. So for this, what I want you to do is get rid of the mod and then just say if x is equal to, let's say 7. Like equality. When I say equal, I mean equality. So this next one is called break. So go change continue to break and run that. So you notice that it gets to 7, x, or 7 is equal to 7, and then we break. We don't print. So break is a way to exit a loop. So let's say, for instance, you are looking for a value. Well, maybe you can do it. I mean, you could do an infinite loop, and then when you find the value, you break. In fact, breaking is that's how, at least I remember when I used to do a lot of the binary algorithm stuff or tree data structure type thing. Like I would have a conditional, and then if it's met, I'll break, and then I can return whatever result I want at that point. So break means exit the loop altogether. This is how you get out of a loop. Now, if you want to get out of a function, you call return. All right, so like break is to a loop as function, or its return is to a function. Yeah, and that's loops. I mean, that's really all there is to loops. So what questions do you have so far?
So for loops, this first parameter here, can you call a function, or is it always just
where? What are we talking about? I wasn't paying attention. What?
Oh, the first
not a parameter.
Yeah.
It's not a parameter. But what about it?
Can you put a function in here?
No. That's a statement. And maybe I should talk about the difference between a statement and an expression. Statements don't evaluate to anything. They're you stating something. So a declaration is a statement. A function declaration, a variable declaration, even an assignment. Technically an assignment is an expression statement. It's a special kind of statement and a special kind of expression, because when you assign to something, it does result in a value, but just not the value that you would expect. If you want to see what that value is, go to your browser, do Command Option J, and then type let a equal any number that you want. Just put a number, it doesn't matter, or a string, or true, false.
Oh, let's put the wrong one. Command
Option J.
Option J. Wait. Okay. Well,
Define a variable.
oh. It can equal anything?
It doesn't matter. You're just doing a variable. See, you got back a value. You got back what?
Undefined.
Exactly. So assignments, they are statements, but it's a very special kind of statement. It's called a statement expression. Now, there are a lot of different, well, not a lot. There are some other types of statement expressions, but for now, it's not that important to note. Just note that with a for inside of that, that has to be a statement. So even though this is a statement expression, the fact that it has the word statement in it implies that it's still a statement. So no, you can't give it a function because technically a function, actually, I don't know this one actually. Try this out. Do function f, and then just do some empty break. No. In where you are in your browser.
Oh. No.
Parentheses. And then curly braces. Enter.
Oh, just run this?
No, outside. You gotta press enter. So I guess that is a function or a statement expression. So given that this results in that, I'm going to say, yes, you can call it. Well, I mean, that's not what you asked. So you asked if you could put a function, if that could be a function. The answer to that is no. However, what you can do is you can evaluate a function and assign that, but that's not what you asked. So one of them is no, you can't just give it a function. Number two is, and the reason for that is because you have to initialize something. That's the key. That's the key word here. You have to initialize something because that value X, you're using it. If you evaluate a function, you're not going to get back a value. And even if you do get back a value, you're not capturing the value in a name, so you wouldn't be able to use it.
Okay, so here you could do then something similar to this.
If you assign the valuation of that to that variable, yes, you could do that. However, that results in undefined. Console log, that gives you undefined.
Right.
Or void. So that wouldn't work because the value, it has to be a value.
Okay.
And when I say
So
a
as long
value,
as this is...
it has to be a non-null or undefined value.
Okay.
In fact, look here, it tells you all of this. So in that for, scroll down where it says syntax, you see it's initialization, there's a condition, and then the afterthought, the increment or whatever. If you read what it says for initialization, it'll tell you exactly what you could do with it. So it's very clear. And if we can actually go and look at the spec too, where it has to be a var RLet. And there's a reason why it can only be a var RLet. Those are the only two non-read-only variable types. The read-only variable type is a const, but we're incrementing, so it can't be read-only.
Okay.
Oh,
Wait,
it's an
what is
assignment expression. Oh, okay. All right, so click on assignment expression. There are a few, there are actually a lot of these. If you scroll down, it should tell you all the different, oh, I'm sorry, an assignment expression is an expression that assigns, but it's also a statement. And I think, I don't know, we had to go into like the spec to really see that, if you really are, if you want to be pedantic about it and make sure I'm not just full of it. So that's the key here, is that the initializer or initialization, it has to be an assignment expression. So it can't be a function. But you can have a function so long as it returns a value that can be assigned.
Alright.
Oops.
Oh, how come you wanted us to do the 3 equal signs instead of like 2?
Because that's the equality operator. 2 is not the equality operator. That's the actually Google, not Google it. You're in the right place. Go to references at the top. Like oh, you're in it. Okay. And what we want to go to the Boolean operators. No, not that. That's the object. To go back is command left bracket. You want to go to the Boolean operators. Just scroll down and look for the word operator. All right, you saw it, equality operators. Roll up.
Oh.
No, click that one and see what it says. No, go back. The one that you were asking about, you were asking double equal, aren't you? So what I'm reading is that this does more than check for equality, which is why I don't call it equality. Equality is it equal, not is it equal. Oh, and I'm also going to convert and try to change some shit. That's what this is.
Yeah, sure.
So you see how it's like 0 equal false? Is 0 equal to false?
No.
But according to this, it is. Why? It's because it's going to attempt to convert that 0 to a Boolean value. Well, what is 0? Is it truthy or falsy?
Falsy?
Yeah. So like now it's going to convert it to a falsy value and then it'll evaluate. I'm going to argue that that's very rarely what you want. Generally, when you're asking if something's equal, you're asking the computer to tell you if it's equal, not to try to convert it to something else and then see if those things are equal. Another one is if 0 is equal to an empty string. Is the number 0 equal to an empty string? To you?
No.
But to this, it is.
Okay.
Yeah, so use triple equal always. The only time that I would say to use double equal is when you are testing like nothing, like the concept of nothingness. In JavaScript, there are 2 explicit ways that we represent nothingness. Well, I'm sorry, not 2 explicit. There's one implicit way and one explicit way. Notice that whenever we created that array and you tried to index into an empty array, you got back undefined. That's an implicit representation of nothingness. However, there's another one that's more explicit, and that's null. Null is something that you will set. So that's the only time where I'll use double equal, because like if I'm testing emptiness or nothingness, I don't give a shit about the difference between null and undefined. They are effectively the same thing at that point. So I use it as a short circuit for that. But in every other case, I'm using like actual equality that most every other language has. It's just JavaScript that has this weird, convert things, and then there's truthy falsiness and all this other crap. So that's loops. What else? What else you got?
So is the fat arrow just for like functions, or could you use it for something else too?
Greater than or equal to.
But you can't do that, right? Greater than, it has to be the greater than and then the equal sign. Right? Or could you also switch it?
To be honest, I've never thought about it. It's muscle memory. Greater than equal to. Oh yeah, you're right. Yeah. So equal, greater than. I guess that's why they did that, or why they were able to do that. In better languages, they used another thing. It was like that I would prefer. But yeah, you can only. Wait, what's your question again? I want to make sure I'm answering.
So the fat arrow, is it only for, defining functions, or could you use it for something else as well?
Fat arrow is all about function. That's literally what they're called, fat arrow functions. Yeah, and search for that actually, because we did cover some of it a little bit, but I kind of glossed over some of the details, like how certain things are optional. Oh, you can close the your sidebars. Command Option J to close that thing.
Command Option.
Or just do Control D. That should also close it. No? Well, if it's not working, I don't know what to say.
I just click it.
Go to that search bar at the top and just type fat arrow. No, like literally fat arrow. Yeah, just type fat arrow, like space. You can press enter. Maybe something will come up, maybe not. All right, arrow function. Oh, it's arrow function. Okay. All right, I prefer that, even though I still think that's a dumb name. Yeah, go ahead and go there. So there you go. It tells you what it is. So that's the only thing that it applies to is functions. And we did talk a little bit about the limitation and how you can use it. I did kind of gloss over this fact that, the binding part, it does this. We won't get into this and that. We won't get into that right now. But it handles that for you. Don't worry about what it is. It's not that important. It's so long as you're using that and you're not doing like class-based stuff, because classes aren't technically a real thing in JavaScript. I mean, they are. There's a class keyword, but it's a little weird where you have to worry about this and all that kind of stuff. So if you're just using functions, you won't ever really have to worry about this that often. But you're also saying that it says that they don't have their own bindings to this argument or the super, which can be helpful in certain cases. And it's saying that you can't use yield within the body. There's a reason for this. There are actually more than one type of function in JavaScript. We've only talked about like the most fundamental functions, but there's also another class of functions called generators.
And to generate a value?
Yeah, somewhat. It's how you gosh, what is it? I think it implements like the iterator pattern where like you can yield a value, like it's for sequences. That's how I think of it. I had to relate this back to C# land because that's kind of how I think about a lot of this stuff. So let's say, for instance, you have some infinite sequence and you really don't need the values all at once. Instead, you want to get the value as you need it. A generator allows you to do that. So let's say, for instance, you had a function that defines an infinite set. Let's say the infinite Fibonacci sequence. Well, to compute infinite numbers is impossible, right? It's impossible. Like, you would be waiting until the heat death of the universe for that to evaluate. But most of the time, when we're doing stuff like this, these types of computations, we don't need all of the values all at once. Generally, we need one value at a time, because we're probably going to pass it off to a loop where we're going to iterate one at a time. Well, we could take advantage of that. We say, all right, well, let's just generate one at a time. So we'll only generate when we ask for the next value. So, yeah, there's that. I don't know if we're going to get into generate. That's, I don't know of many developers who've ever done. Well, I know a lot of these, like I know, so I've done them, but I don't. Most developers, I don't think most developers have ever really had to use or define generators themselves. They may use generators. It's kind of like if you're building a library, like you're likely going to be writing your own function generators or generator functions. However, if you're consuming it, you're not going to be writing it. You're going to be consuming it. The best case, or the most popular use case of generators is with async await, which is how we are able to deal with concurrency in a synchronous manner. So like we could write code that looks synchronous, but that is asynchronous. And if you know what the word synchronous means, you should be like, oh, that doesn't make sense. And you're right, it doesn't. Yeah. Which is why I would have said it's just like concurrency. So it allows you to write your programs as if they aren't really concurrent, and you can reason about it easier. So, you know what? Maybe this is where I can take over. I can do a little bit of something, showing something.
Oh, okay. Yeah, let me stop sharing them.
Oops. You spoke. You were on my stream now.
Oh, I'm sorry.
Yeah, you gotta wait. It's my fault. I probably should have told you to wait for a little bit. Oh, man. All right. I thought I had Visual Studio. Man, I didn't even know I didn't have anything open. I thought I had Visual Studio open the whole time. Wait, what am I showing you again?
Generator?
Oh, yeah. I'm not really going to show a generator. I'm going to instead show like a use of generators. But if you really want to see how they're made, it's you'll do like a function that, and then you'll do like the star thing. I'm sorry, it's function star gen. And then yeah, it's something like that. But we're gonna talk about how you can create, or not create it, but use one. So I'll create a function. We'll call it async fn. Async. I cannot spell today. Async. We're also gonna make this bigger. What the fuck? Zoom in. All right, cool. So we're gonna have our async function, async fn, and this is going to be an async function. So this is how async is working. It's creating a generator behind the scene. So we'll do that. And because this is an async function, we have to like return a promise. We won't get into too much depth about that right now, but we'll just return a promise and we'll resolve it immediately. And promise only for us to type, but it's being used as a value. What the hell? Yeah, I'm pretty sure I can do this. So I'm gonna go ahead and call my, oh my gosh, this is gonna annoy the hell out of me. I'm gonna go ahead and save this because like I will start cursing if this shit continues to happen again. Let's call it a.ts or js. What did I do? Hold on, give me a second. JavaScript, that's what I want. There we go. All right, cool. So TypeScript was getting upset at me. It's like, oh, you can't do that, but I can. All right, so we're gonna do async function, and let's resolve with hi. I don't know, hi like that. Okay, we're gonna call our function, and I want to say, can I wait? Yeah, I can. So we're gonna wait the value of this, and we're gonna assign it to a variable. We'll just say a, and we get back hi. Right, so what's just happened is when we use this async keyword behind the scenes, in the runtime, there's some magic happening where it's going to go off and create a generator function. And when the value is ready, then we're going to call it and we're going to get that value. That's what this await part here is doing. So let's drive home the point. Instead of returning a promise where we resolve hi, what I'm instead going to do is do a set timeout. So we'll say we're going to give it a function like so, and then I'll say set timeout, and then we'll wait 5 seconds. So we'll say console. We'll define a function like this actually, console log. And then we'll say the same thing, hi. And then here we'll wait for 5 seconds. Like that. Oop, oh my gosh. All right, so now eventually, hopefully, at one point, we will get back hi. Maybe. Or maybe not. Why am I not getting back my hi? Give me a second while I think.
Is it because it's waiting for the timeout?
Well, it should only be 5 seconds. Unless it's not 5,000 and it says it's 500. I don't know. It should be 5 seconds though.
Is that 5,000 milliseconds?
Yeah. Huh. Interesting. Let's see something right quick. Let's see. This returns a number.
It should be. Yeah, you're right. It's 5 seconds. But to me, that's seconds.
Oh yeah, that's what it should be. It should be seconds.
Well, no, it should be 5,000 seconds. Is what I'm thinking.
So
I think you're running in like 5 minutes.
No, it's me being dumb. It's
Or, yeah.
Let's run the thing. Now it's not even running. It's like, oh, there it goes. We're good. It's running now. All right, there we go. All right, cool. All right, that was the issue. What happened? This right here returns a function, and I forgot to actually call that function. So yes. So when I call a, it took 5 seconds for it to print hi. And it's using generators for that. Give me a second. Well, what's up, M? Got a question. What do you think about that state of AI at this very moment in time? What do I think about AI? It's okay. It's I don't know, like it has potential. I'll say that. Generally, it's not. I don't think that we're going to be really moving like to multimodal AI models or general AI. I think that what OpenAI introduced earlier in the year with this concept of assistants. I've always called them as agents, but I guess assistants is the word we're going to use now. where instead you have these smaller AIs, generally like language models. Some of them could be diffusion models. Some of them can be whatever model, like whatever model you want. And instead they specialize on specific things. I think that's probably where we're going to see a lot of really interesting things start to happen in the future, where you have these smaller, very specialized AIs, very similar to how corporations work. A lot of times you go into a company and you have people who are specializing in different things, and you have a hierarchy where you'll have a director or a manager who like orchestrates or coordinates the work of many different individuals into something of value. So I think that's kind of where we're going to be heading with AI. So the current state, I think it's still a lot to learn. There's still a lot of research happening. I will admit that I'm not as in the weeds as I once was when it comes to AI, but broad strokes, I think that most of our progress is going to be with these smaller agents. Now, obviously, we do have certain companies who are trying to focus on multimodal AIs. Like Gemini is the latest one. I think GPT 4.5 or maybe 5 will likely be that, which that's approaching general AI. But I don't know. I still don't believe that we truly understand intelligence. I think we as humans, we have a lot of hubris where we think that our idea of intelligence is what intelligence is. And yeah, now that I've been around animals and I'm like, I see things, it's just like, man, like there's so much more that we don't understand. So when it comes to the language model stuff, yeah, I think that's okay. It's not really producing anything new. And that's one observation I've noticed, that we've been having these AI things for a while now, and not one new discovery has been made. So to me, that's telling me that there is no creativity. All it is derivative work. So that's my hot take. Anyway, sorry about that, y'all. Yeah. Actually, I think what I may do for you is show you async await in action instead of me just trying to come up with a contrived example. So here is one of the things that I was working on, not that, but this. And we're going to step through this right here, Elizabeth, and you, Kyle. I think this is helpful for you as well. And I want y'all to kind of like, tell me what you think is happening, and I'll kind of guide you along, right? So what we're going to start with is these functions here. Don't worry about the names of the functions, and don't really worry about these type annotations. We'll get into that, but let's walk through it right quick. Let me turn up my music a little bit. It's a little loud for me. All right, are y'all can hear me still, right? Y'all can see my screen?
Yeah, I can hear you.
Okay. All right, so we're gonna start with this function that's called loader. And I'm going to introduce some TypeScript stuff, but don't feel like you really, really, really need to understand it now. Just keep in mind that for the most part, like I know TypeScript, like I know a little JavaScript, but like most of my JavaScript knowledge is because of TypeScript. So we have this function, and we have this weird thing right here. What do you think what is this called? How about this? Let's call it R. What is this called? What vocabulary, what jargon did I give you for that?
Was it a variable?
No. Kyle, what do you think it is?
Well, I don't know this one. This file, like a permission?
Nah. I'm sorry. Let me. This thing here. What is that called? So we have a function definition. Ignore the fact that it's async. We don't care. We have a function definition. When you get to function definitions, you have what that you pass to it. Like, what do you define? What are these things called? If I do like another one, ABC, what are these things called?
An argument? Or arguments?
Arguments are what you call.
Oh. Um,
Excuse me.
Parameters.
mm,
These are parameters. So this right here is a parameter. Now we're doing something that I haven't showed you how to do yet, but this is called destructuring. Destructuring is you can pick out the keys that you want from an object. So when we pass this parameter here to this function, this is actually an object. So if I rename this to A, for instance, and then I do A dot, I get back context params request. This is an object. The cool thing about when you are defining your parameters is that you can destructure that object that you're going to receive in line. So you don't have to like do A and then do A dot whatever. And I can show you the other syntax. So if you do this right here and then you say equal A, you get the same thing. Context, request, whatever the things are params. So this is just a shorthand way of doing that here. So we could just say here, we'll say context, params, requests, same thing. All right, so our first order of business is we define a function and we're going to destructure the object that this function takes, and we're going to pull out the request. All right. And then here, we're going to pull some things out from our cookie. We have a cookie. So I have a function that loads cookies. We can look at that if you want, or we can just trust that we're going to pull out some values that I have named MailChimp API key, OneSignal app ID, and MailChimp server prefix. And then I want one of you all to tell me what happens next. Because the goal is for y'all, like I know what this does. You all need to tell me what it does, because I already know. It's not helpful if I tell you. I mean, obviously I wrote it, so obviously I know what it does. And for those who are watching, one thing to keep in mind is that most of what you're doing as a software developer is reading code. So if you want to be a good engineer, you have to be good at reading code, period. There's no way around it. You're not a good one if all you can do is write code, because half the time, not even half the time, I would say maybe 90% of the time, most of what you're doing is reading what's there so that you can make modifications to it.
Is it?
We're on line 35. You can just read
35?
read what the words say
Oh.
out loud, not in your head.
It returns the.
What is JSON? Like what? Just in the context of here, not like what you think JSON is. What is JSON? What is that?
A function?
A function, yes. So you're going to return the evaluation of whatever JSON evaluates to. The actual thing that you put in here, I mean, sure you could talk about that, but it doesn't matter. At a high level, you're going to return whatever the result of this is.
Hey.
Now, given that it's called JSON, what do you think it does?
Some text.
What is JSON?
I was muted. Shit. JSON is it's a JavaScript format that response. It's I forget what JSON stands for, but I know JS is JavaScript.
Okay, so we got the JS part, the JavaScript. What is this right here? I know we didn't. Well, I literally just talked about this. What do you think these curly braces here mean? Or what is this? What is this parameter type? What's the type of that? I just said it not long ago. There's one thing that you can say where you will 100% always be correct, because everything in JavaScript is this type.
It's an object?
It's an object. So this right here, what is that?
Object.
An object. No, it's just an object. It's just one. We only have one pair.
Why is it just one though?
Because we have
it's separated.
Well, these are. Yeah,
I'm thinking comma separation. Yeah.
Nah, we only got one. So we have an object. So what do you think the O in JSON stands for?
Object.
Okay, yes. The N, I don't think y'all are gonna guess this one. It stands for notation. So it's JavaScript object notation. So it's not a JavaScript object. It's just notation. So let's look at JSON right quick, like an actual JSON value. So let's see. We're gonna open up ChatGPT right quick. So give me some dummy JSON. Okay, so we got an example of JSON. Oh, man, I don't need this much. God damn it. All right, well, anyway, I guess we'll just use this. So you see here that each one of these keys has a quote. So all of the keys are strings. And then there's a colon. And then there's a value. The value can be only the JavaScript primitive values, of which there are 7, except there could technically only be 6. Symbols don't count in this case. Don't quote me on the symbol part. So it can only be the 6. I'm 98% sure that it can only be one of the 6 primitive types. That is a string, a number, a Boolean value, an array, an object. Wait, how many things have I? Wait, am I counting right? Have I only said 4? Repeat what I've just said. I forgot. I forgot what the hell I just said.
String, number, Boolean.
Do you see that?
Oh,
List.
an array?
Yeah.
Or
You see this? What's that? Maybe,
right.
maybe it'll help if I highlight this. What do you think this is? What's that? The O in JSON.
Object?
So, what do you think this is?
Oh, just an object.
And it's an object because it has these right here. That's how it's an object literal. This is what denotes an object. So anytime you see curly braces outside of the context of a function or block, it's going to be an object. That's the literal type. All right. And then there should be one more. Let's see though. I actually don't know. Is null a possible value here? I think it is. Yep, it is. So that's the other one. It's null. So it is 6. I was right. All right. So that's JavaScript object notation. If you are really interested in JSON, I forget who built it. The guy who came, Douglas Crawford, I think. Let's see, Douglas Crawford. Yeah, he's the inventor of JSON. The JSON format here, and we should be able to find the format or specification. No JSM.
It's a RFC 8259.
8259. Let's see if it's in here. 825. Why is it not here? All right. RFC 8259. So just for what it's worth, Elizabeth, Kyle he's in DevOps, and he's also fairly experienced, just like me. And I want you to notice what he was able to do within a few seconds. He was like, it's the RFC number. Remember when I was like, find the HTTP stuff and you were looking at RFCs? Mm-hmm. Oh yeah, Nick, you see, it's not just me. It's something that's really useful. So if you want to learn about JSON, like for real, like all of the ins and outs, what you can do if you want to build your own parser, if you want to build your own like thing that creates the JSON up, like a serialization type of thing or deserialization, this is where you go, where you can learn all of the ins and outs of JSON. But I mean, technically you only know you know enough at this point, I think, hopefully. All right, anyway, so this right here is going to return JSON. JSON is literally a string, right? It's just a string that we can then parse into a JSON object. That's what makes it really cool. It's that pretty much all of the symbols and all that map directly to JavaScript types. So it looks like JavaScript objects, even though it's technically not. It's the notation of an object. So yeah, so that's what this loader is doing. We won't really get into like details that much yet. Next, we're going to go into this action. I'm going to tell you from a high level what this does. So with web pages, whenever you submit a form, it's going to generally post to a server. That post is a result of whatever the action on that form is. If you're curious about the action on a form, that's also specified in the spec. So just think that whenever I'm on another page or on this page, whatever page, I'm going to make a post to the server from a form. This action is the thing that takes that request and parses out all of the form data so that we can do some stuff with it. So we're going to walk through it. So what are you all, what is this? What is this doing here? Explain that to me.
It's taking the request, so it's acting on the request, and then that's chasing the action function args.
Just 38. It's the same as the last time. I introduced a new word. It starts with a D, and we do it to objects. People watching the stream, y'all can feel free to answer too.
Restructure?
Yes, we're destructuring an object. Here, just on this line here. We're just destructuring an object. All right, so we're grabbing the request property. So objects have properties. So this is another jargon word for you. We're going to pull, here's another jargon word. We're going to pluck out. There was an operation in, gosh, what was that? It was back in the day when computer scientists were starting to get more involved in the web sphere. And they started bringing in these other types of I think it was Backbone. Is it Backbone JS? Is that the thing that I'm thinking of? I'm sorry, I'm not really familiar that much with web stuff, but I think it's Backbone JS. And let's see, pluck. Yes, yeah, here you are. So this became like a thing, right? So plucking is you have a collection of key value pairs, aka an object. That's what an object is. It's literally a collection of key value pairs. In fact, you can even think of it as an array of key value pairs, where the indices of the array are they're indexed by content, by like the by a string, right? So we'll hash it and then we can get back out the value that we care about. So pluck allows you to specify the values that you want from an object. Because let's imagine that an object could have 100, 500,000 of properties. Maybe you only want a few of them. So you'll pluck out the ones you want. I think that's why they use the word pluck, because it's like you're like plucking out a feather. You know, you just pluck the ones that you want. So in this case, yes, this is destructuring, but if you want, you can also say I'm plucking the value request out from the object. All right, next, what is this line doing? Just read it like out loud, and that may answer what it's doing. Someone, it doesn't matter who's.
It's assigning a new constant to this request. No, this get function.
Yes, I heard some things. That was right. Okay, so here's how I'll describe it. We define a constant and we call that constant cookie header. We assign the value of this function call of get. Well, the thing is that yes, this is a function, but we have to get to the function in the first place. And this is going to be the key differentiator between JSON and a JavaScript object. Because in JavaScript, an object, one of the keys can be a function. You can't define functions in JSON. So that's one key differentiator here. So to get to this function, we first have to go to the request object, the one that we pluck out from our action function args type thing. And then this object, it's an object because it has a dot after it, it has a headers property. So we go to the headers property. Well, this headers property also happens to be an object. And it happens to have a key or a property on that object called get, which is a function, a callable function actually. And then that function takes in an argument. In this case, it didn't really matter what the argument is, but in this is cookie here. So we're going to get the cookie. Now let's zoom out from JavaScript and think about what's happening from HTTP land. So let's open up Rapid API. And this is something that like you may know a little bit more about this. Let's see. I had to find a project that's easy for me to show off right now. One second, API. Yeah, we'll use this, I guess. Okay, so what I'm gonna do is create a new request, or a new project rather. And we have a basic request. This is HTTP. We'll look at the raw HTTP. Make this a little bit bigger. Okay, so you notice here that we have a HTTP request. You see it's got the verb, it's got the protocol, like which HTTP. Remember you were looking at that earlier. There's more than one version. Like there's 1, there's 1.1, there's 2, there's quick, there's all the other ones. I don't even know all the other ones. All right, so we have here some header information. Header information, that's the key. These are headers. Headers are literally just key value pairs. In this, I think they could either be a string or a number, or maybe a Boolean value, which may just be strings. I'm not sure. So let's come here and let's add a cookie, for instance. So we'll say headers, and then we'll say cookie. Notice what you see here. We get back cookie here. So what this line of code here is doing is it's going to the request that the server has received. Because, you know, remember when I send this, this is a request that I make to a server. And this is where we get into that full stack stuff that you were talking about you wanted to learn. We're going to make this request to a server, and that server is going to parse that request into an object that you have access to. In this case, in our server, the request, we call it request to denote the fact that it's the request. And we go to the headers, you know, the headers. All requests have headers. That's what this is. And then we say get, and we give it a string. It's just going to look for, it's going to do a string match. It's going to look for the header that has the name cookie. And once it does that, it's going to get the value of that. So let's say that I put a value, this is a cookie. It's going to give me back, this is a cookie. So that's what this line of code is doing.
Mm.
Make sense to everyone, not just you?
Wait, how come you put it as a constant though? Like, do we not expect that to change?
Why should it change? Why would it change? Think about it. Who is it coming from?
Oh.
Yeah. So it's read only because it helps people like me and you avoid making stupid mistakes where you're like, oh, I'm gonna go change this. It's like, no, like let's use our language to make sure we don't create additional foot guns. So I am a person that defaults to const, and I only use let when I need to use it, which is to say, oh, I need to reassign this value. At that point, I'll change it to a let, but my default is always const. And what you'll notice is that most of everything that you see here is const. So that's a pro tip for you. Like, you could be like, oh, there's this difference between const and var and let. Just use const. Never use var ever.
Yeah.
And then use let when you need to. But I still haven't gotten an answer to my question from both of you. Does this make sense? Do y'all understand that? And you're muted, Kyle, if you don't know if you're muted. Or I don't even know if you're here, to be honest.
Yeah, I'm here.
So assigning the constant cookie header that whatever value from the get header request for cookie.
Well, I get what I'm asking is, does it make sense that this line of code gets this value?
I think so.
Kyle?
Because it's going from requests to the headers, and then get is just a function that's available to, I guess, look up cookie.
Get on headers gets whatever string it matches these, and it gives you back the value.
So if cookie wasn't like there before in the header, would then this just be assigned like an empty value, like an undefined?
Yeah, specifically that one. Specifically undefined.
Okay.
Because that's the implicit value. Only null is explicit, so it would never return null unless you somehow were able to like give a value that resulted in null, which I don't think that's possible. All right, I'm gonna move on. I'm assuming that you're good. So next line, go ahead and read it. Just read it. Don't worry about what you think it's doing.
Assigning the constant cookie. Oh.
You know what? I'm gonna do something right quick. What is this called? Not the let part, but like, what is that whole statement called? What are we doing?
You're assigning a variable?
No.
The heck is let?
In order to assign a variable, you must use an assignment operator. So if you don't see an assignment operator, it cannot be an assignment. This is for you, Kyle, because I think you may have, know enough about C to know this one. Back in the day, you remember at the top of your main file, you will have like a bunch of variables that you've defined. You remember that?
Yeah.
What were those things? What was that called? Like, it starts with a D, but it's not defined.
I mean, declaration?
Yes. This is a declaration. We're declaring A. And I know it may seem pedantic, but it's important to understand this. So we're declaring A. And then if we were to do this, what is this doing?
Now you're assigning it.
Yes, I'm assigning the value 10 to A. Now, we've done this, but there's a way that you could do this all on one line. We can say let
and then
B equal 10. Now, this right here, this line, is the same as these two lines. This is a compound statement, essentially. Like, we are declaring a variable and assigning a value to it. So when you read this, what are you doing?
Constant's just taking that and there's two lines that you created into one, and then that one is just constant.
Well, the constant part is still a variable, and I think that's the key here. It's still a variable. So what you're doing is you are declaring a variable cookie, and you're assigning whatever the result of this is.
And then you're taking the cookie header that was returned previously. So this is a cookie.
Yes.
And you're parsing it, but I don't know what it's looking for.
When you say looking for, what do you mean?
The parse portion is just it. Oh, you're just assigning the entire returns value into that.
Yes.
Variable. Yeah.
Yes. Now, what do you think the type is of this, of cookie? What do you think it is? Just based off of this part that's highlighted. Do you see any?
Object.
Yes. It's an object. The hint,
because of the brackets.
Yeah. So this right here, this is another type of operator. This is an OR operator, but it has a special meaning in this case. I won't get into that right now, but actually I will. No, I won't get into that right now. I won't get into it now. But the key insight here is that either I'm going to get the object that this evaluates to, by the way, that's what parse is doing, is taking this cookie, which is generally going to be base 64 encoded and potentially encrypted with whatever server secrets there are. And it's going to then turn that string into an object that I can then do some stuff on. Now, this await, for what this works, anything with an await can fail. So that's what this right here is. It's like, all right, parse the cookie, but oh wait, if you fail or if there's no cookie, then just give me back an empty object. So no matter what, I'm getting back an object. It could be empty, but I get back an object. Now, maybe it would be useful to show you what this cookie looks like, so that I'm going to assume y'all don't really know what cookies look like. They're not really magical, but they are how we have state on a browser or something like that. It's a way that we can, because like one thing to keep in mind about HTTP is that it's completely stateless. Stateless means that each request is they're all different. Like nothing is saved. So if you make a request, the server doesn't know who you are the next time you come back. The only way that we can know who you are is that you have to tell us. So the way that we solve that problem is, once we know who you are, we create a cookie, we set it in your header, in the response. Your browser is going to store that cookie, and it's going to use its own magic to do that. And then every subsequent request, the browser will include that cookie. So the server could then read the cookie, aka parse it, and figure out who you are and like maintain session and all that other kind of good stuff. But anyway, let's go ahead and open this up in this thing. For what it's worth, I normally don't use, you know what? I'm not going to use this. I normally don't use Arc for development. So let me open up the thing that I actually use. I'm going to do here. And I'm just going to put in a value so that we can get the cookie to actually work. And let's go look at it. Come into storage. And you'll notice here that we have this thing right here under cookies. See? Localhost. And then we have two keys. We have prefs and whatever the hell this is. Now, let's go and look at this cookie thing here. You see prefs cookie? Does that look familiar? Prefs? Prefs over here? Prefs? Let's look at the thing. See here? Create cookie. Prefs. Here's our cookie. Prefs. Let's get the value out. Let's see what this value is like. So we'll go ahead and, okay, I guess we can't do it that way. Oh my gosh, this is going to make my life hard. No, it's not. Yeah, it is. Okay, so I'm going to have to do something weird. Just ignore this step. Because this is in a browser, it's URL encoded, so I got to de-encode it. So now we get this. And you'll notice that it ends in 2 equal signs. Just hint, if you ever see a string from a browser or from a server that ends in 2 equal signs, it's generally a dead giveaway that is base64 encoded. How do I know that? Well, base64 encoding, it has to be a certain length, and we use the equal sign to make sure it's that certain length. So like if it ends in equal signs, then this is that. So now that we know that this is base64 encoded, I'm going to go into here and paste in this, and look at that. That's the cookie. So we have the base64 thing here, and then I decode it, so I get back the actual cookie, which has got some keys on it. Properties, remember those things? MailChimp API key, OneSignal app ID, MailChimp server prefix. If we come here, we will notice that we have those same keys. We have whatever the hell I just said. I don't know what I said. MailChimp API key right here. I've defined this as a const. The reason for that is that I can then go inside of my object and say, give me the MailChimp API key, that name there, which is going to give me back whatever MailChimp API key is, which is going to give me back whatever the value is here. So if we go back to here, this cookie object it's literally this. So that's what we're getting back. That's the cookie header. In fact, we can go even one better. Let's go to network. We'll reload. And actually, let me go to close or clear all of these. Okay, so we get back this right here. And if we go to this MailChimp, let's go to the request. And you see here, cookie. There's a cookie here. This is the cookie that the browser is sending to my server. So if I were to get the cookie out, I would actually be able to see this value. Now, this value doesn't make sense to anyone. So we would have to then parse it so that it does make sense. That's what the parse is for. That's what this is for. So now that we got that, we get the cookie out. The next thing is what? What are we doing?
You're trying to get the form data. What's the form data?
The form data. So remember when I introduced this action and I was like, this action is what the form posts to. So inside of a form, here, let me show this actually. I think having the doc would be useful in this case. NDN form element, and we were looking for action. So here, all forms have an attribute. By the way, these are what those are called on HTML tags. All of the alphanumeric key equal. All of those are attributes. So you have the tag and a list of attributes. On the form, one such attribute is action. And here it says the URL that processes the form submission. So in this case, there is a form that points to this endpoint, MailChimp/download. And that form, the data, and I'll show you that right quick. Oops, how did I do that? I'm dumb. So here's the form here. So when I click this generate export, I'll do it just so you see. Pay attention to what happens here in the URL bar. Download. You see here? Download. So that form data is posted to this page, or this route. This is technically what it is, this route. And the thing that handles it is an action. And this is just remix. This is about remix at this point. But I mean, at any point, like you can, if this were another server framework, you would have to do it yourself. But with Remix, they have like a pattern for how you do it. And they have this concept of an action function, which gets called anytime it receives data from a post, from a form submission. So that's what's going on here. So it's just this. All right, so the reason why we await is because this could fail. Like maybe there's no data because this is user land. Like, you ever heard that saying, you can't trust user input?
Right.
It's that. So we try, and that's what await, remember, whenever you see await, you should always be thinking, okay, this returns a promise. Oh, if it's await, then that means that it can fail. Oh, if this can fail, then your thought process should be, I'm trying to do this. So I'm trying to get the form data. I'm trying to get parse. And to make this even clearer, generally, and I'm not doing this here, but generally, anytime you have await or async or whatever the hell it is, you're going to put this in a try block. So like you could just think of it just like whenever you see await, you're trying to do that. Okay, so once we get the form data, next thing that I do is I'm going to try to get specific values out of the form. So it turns out that this body is an object. How do I know it's an object?
I'm not sure.
How about you? Like, I need a response. I'm happy to wait, but like I need a response.
Yeah, I'm also not sure.
Remember when I said that anytime you see a dot, that it implies that the thing is an object? So we have body here. What do we have here?
Dot get.
That's how I know it's an object, because I have a dot at the end of it. So we have an object and it happens to have a function. How do I know that this is a function?
Parentheses after it?
Yeah, parentheses. So it has a function, and turns out I can give the function a key, and then it will give me back the value that matches that key. So this is going to essentially parse whatever the form data is and give me back a JavaScript object that I can actually index into using this get right here. So we're going to get these values, and the add string part, this is all TypeScript, because to be honest, this is user stuff. We don't know what they're giving us. And right now I'm like, because it's me, I'm just going to convert it to a string and treat it as a string. It may not be one, but I'm treating it as such. Next thing is I have my cookie, and this is something a little bit new for y'all, but like it's not that new. I have a cookie, and then I'm going to index into this cookie, and I'm going to assign a value to it. So I don't think y'all really get this. So what questions do you have about this one?
This one, you're modifying the constant, or the variable, correct?
I'm not modifying the constant, but I am modifying the cookie. And this is where we're going to
is this a replacement, or are you adding to the object? You extending the object.
In this case, it's going to be either or. Like if the key doesn't exist, it will add it. If it does exist, it'll override it.
It'll replace it.
Yeah. So I think this is a really important point to make. Is that when you define a read-only variable, what that means is that you can't reassign to that variable. In other words, I can't say cookie equals.
So if it exists, you're not going to be able to overwrite it, though.
Yes, exactly. But because this is an object, technically, all I'm doing is modifying the object. So have y'all ever heard the difference between reference types and value types?
Yes, I have.
How about you?
No, I haven't.
Okay, so you can think of this cookie as a reference type, and that const is saying that you cannot change what this thing refers to, the memory address. You can't change that. However, the actual data that's a part of that object, you can do whatever you want with. So that's what we're doing here. So this is another way to index into an object. So you saw one. So like if we have an array, for instance, so we have const a equals this. We saw that you were able to do this right here. Put in a number. Oops, let me not call this const a. Wait, what? I don't give a shit. Like this is my linter complaining at me, but whatever, we'll fix it. We'll just do this. Okay. So
I've been chasing linter all night.
This is how you index into an array. The thing is that with an object, the only difference between, well, it's not the only one. There's another one. The biggest difference between indexing into an array and an object is arrays use numbers, whole numbers, whereas objects use strings. So if I do, let's say const b, and we say that this is equal to an object, if I want to index into that, I can say this, like so. Now the reason why this is failing is because this is TypeScript, so it's not happy about this. I would have to define it as any, and then it'll let me do what the hell I want. But I'm not gonna do that. So like I could put a value in here, and then if this were regular JavaScript, I can say b dot this. Technically it can't be this, my bad. Let's call it THS. And then that will give me back 6. So this right here is equivalent to doing cookie dot that. Now I can do this, but I chose to not do this because I wanted to make it extremely clear that this value here is not the value that you're getting on the key. I'm sorry, on the object. This value is itself a string literal. So that's why I have it here. It's because it's a string literal. So if I hover over it, it'll tell you what it is. It's MailChimp API key. Whereas if I were to try to do dot that, it would actually fail at runtime because you can't do dashes like that. That's not valid. A valid key in JavaScript land. Because hopefully, and I hope this makes sense. If I do mail minus chimp, this is interpreted as a minus. That's why it's like this. So what these are doing is I'm going to this cookie and I'm saying, all right, assign this value to this cookie at this value at this property. And we do that 3 times. And if we look closely, I mean, you'll see it here. Oops, not here, my bad. Here, those 3 values: MailChimp API key, Ronstone app ID, MailChimp server prefix. That's how those values get stored in the cookie. All right, so next, ignore this, ignore that. And then we return JSON, the same thing. This is the response. Remember, when you make a request, generally you want a response from the server. Well, in the response, turns out that you can send a header called set cookie, which is going to inform the browser to set a cookie, aka do this right here. And notice that the cookie that I'm setting it to is this. I'm awaiting again, remember? So I'm trying to serialize the cookie. The serialized cookie looks like this EYJ, whatever the hell. So that's actually what gets sent to the server. I'm sorry, not to the server. I'm sorry, to the client. It gets sent to the client.
Wait, how come you have is serializing it encoding it?
Serialize is a very specific verb that means to convert this, I'm going to call it this abstract object within JavaScript into something that can be sent across the network. Like at the end of the day, like all of this has to be sent over the network, TCP/IP, and that process is serialization. Like we get it, we actually turn it into raw, like binary or electricity. Technically, we send it, we turn it into electrical signals or current signals, not current. I'm sorry, electrical signals. So serialization is that whole process of turning it from this abstract representation to text to binary to electrical signals that go across the wire across your NIC, and it gets sent to the other side, another computer, where it will then deserialize that data. And then that's where you can then parse it. You know, parsing is different from deserialization. So you'll parse it, which will then turn it back into that abstract representation that we want to work with in our programming language.
So what happened here was you grabbed the cookie from, from the server, and then you reassigned it certain values based off of what the submission of the form from the user, and then you serialized it, and then you sent it back to the server, right? Is that?
Yeah, no, almost.
No.
This request comes from a client.
Oh.
This is like what you're looking at. This is running on the server, so this request is going to come from the client. We're going to attempt to get the cookie from the client. There may not be one, which is why when we try to parse it, I know that there may not be one. If there isn't one, we give it an empty object. And because we can assign new values, or like we can, insert keys into an empty object, that's what I do here. So by the time we get to here, assuming that there are actually values here, there will be values here. And at the last part, like I had to send it back to the client in the response. And that's where we serialize the cookie to get it ready for that. So I guess one thing that maybe you'll, I don't know if you're noticing it now, but understanding who is who, like the actors in the system, is incredibly important. Like, yeah, you have a server, and yeah, you have a client, but like you have to keep in mind like what direction is communication going, and like what's happening on the end, like on the ends, so on the server and on the client. And that's just this part right here. There's obviously more that we're not getting into, but this is that. When you said full stack, I imagine you meant like full stack web, like from a web perspective, and not like full stack from a general engineering perspective. But if you meant the other one, we can get into that too, because yeah, that's actually that's the stuff that I actually do, which is like a lot of other things. So that's going to be it for this function. I mean, there's not much to it. This is just trying to get you in the mindset of thinking about HTTP requests and what's happening on the client, on the server. Obviously, you got to understand how your browser works, and you also need to understand how HTTP works, as well as how whatever the tool that you're using. In this case, I'm using Node and Remix. You got to understand how that works. And there's other things that you got to think about as well, which is like these other headers that let me pull up a request on this network. Oops, wait, why did that? Okay, so we'll come here. So here's all of the headers that are being sent to my server that's running over here. All right, so we have, let's get rid of the response headers. So this is what the server sent back to me right here. This right here is the request that the browser made to my server. So it made a GET request to this route here, MailChimp download. And then it received a 200 OK response from my server using version HTTP1. It transferred 2.81 kilobytes. Notice here that it says 8.42 kilobytes in size. We'll get into that, why there's a difference. We get a request priority as well as a DNS resolution. Like, how is it resolving DNS? This is local, so it's going to be the system. Now let's look at the request. The browser is saying, like, when it's not just a browser, but like for now, just pretend that it's just a browser that's in charge of setting these things. It's defining what the client wants, what the client can accept. So it can accept text HTML, aka HTML. It could also accept XHTML, which is XML, extensible HTML. And that's application because it's an application protocol. It's also application XML. And then there's this Q0. And then there's also this image, AVIF, image WebP, which is a type of image compression, as well as some other stuff. And this, I think this Q is the quality or something like that. I forget what it is. But the idea is that how does the server know what you can parse and what you can process without you telling it? So that's what this is. It just turns out that the browser does a lot of that for you. Now let's get into how this can be transferring 2.81 kilobytes, but the size is actually 8.42. And that's what this is right here. The accept encoding, gzip deflate br. So gzip is a compression. I'll show you that. So all requests are generally compressed. So let's look at gzip. And this is an open source compression algorithm. And if you really want to, like, you can go and look at the algorithm. For what it's worth, compression is like a thing that, like, I love compression. This is actually one of the things that I love most about computer science, which is this idea that you can take advantage of entropy and like what are you doing? What the fuck? You could take advantage of entropy in a system, and like you could use that to your advantage to remove information, well, not information, remove data and keep the information the same. To me, that's just like that's awesome. And it's very useful because think about it. If I'm sending you data, like for instance, we're doing this real-time chat, I'm able to stream and all this kind of stuff. Do you understand how many megabits per second that this camera is actually outputting? Versus the fact that I'm able to, you know, have this conversation with you with audio, with video, your videos come in here, Kyle's audio is in here, I'm streaming to 3 different platforms. I'm able to do all of this. If there were not compression and, you know, these other techniques to, you know, to constrain the file size, this would not be possible. So compression is like, it's a fundamental problem in computing. Like, you can speed up processing because you can, you know, send data across the network, and at a certain point you can only do so much with a single computer, and you need to have multiple computers together to accomplish any task. So if you're sending terabits of data, you know, every, I don't know, hour or day or something like that, it would help if you can somehow compress it so that maybe it's not terabits, but maybe it's gigabits. So yeah, anyway, that's enough of that. Let's go back to the thing. All right, next thing is we have another header for accepting the language. Right, for now, like it doesn't really do anything. I'm not using it, but it's something that we send in every request so that if the server wanted to serve you content in a specific language, you can say, give it the two-letter language code. So let's say you wanted it in Chinese. Well, you put CH, and that would give you, if the server supported it and they're looking at the header, they can say, oh, well, this response, let's make sure we give it to them in that language. Cache control, I think this is where Kyle comes in. This is like networking and CDNs and all that kind of stuff. One of the things that's really is really complicated is caching and cache strategies. Caching is simply storing, well, do you know what cache is? Oh, okay, Kyle had to drop, my bad. Do you know what a cache is? Like a weapons cache? It's just a small place to put data, or not data. It's a place to store something. That's what a cache is. So with web, because it's a lot of networking involved, maybe we don't want to have our server always giving us responses for things that don't change or for things that don't need to have an updated response. So we can say cache, no, this result isn't going to change for the next day. So next time when the person asks for it, specifically the user, instead of going to the server, the browser will look and say, oh, well, the server directed us to cache this information. We'll just look at the cache and grab it from there. And that results in significant speed ups, as well as reduced bandwidth use and cost and all of the above. Yeah, and we could go over some of these, or what you could do is, you will find this in the HTTP spec, where it's like, what are these headers meant to be used for, and all that kind of stuff. But I think this, maybe this could be enough. I know this is a lot. Yeah, there's a lot. Oh, and Kyle, he has this to say. I'm gonna throw it up on screen. I know you won't be able to see it, but I'll read it. Cache headers allow things to store and forward in browser or CDNs. What he has to say. And I'm sure you've heard of some CDNs. What's the one? What are they called? I forget who they are. But they're like the big one. They're like the main CDN. If you go to most places on the internet, Cloudflare. That's what it is, Cloudflare. Have you heard of that?
No. I don't think so.
Here, let me show you something. We're gonna go to Google, and let's close that, and we'll open this. Refresh. Okay, we'll have Google. Okay, and then this is actually, if you really want to learn how the web works, you come here and look at you look at the requests that are being made. This is everything your browser's doing, and it's giving you all of the information that the server's giving to you, as well as what is sending to the server. So you can get a lot of understanding for what's happening. So while I'm doing this is I'm trying to see if Google is using Cloudflare, but now that I think about it, I don't think they would, because they're Google. So let me go to another site that may use it. New York Times. Wait, look at the image on the website, or like at a news site. Okay, yeah, let's go to CNN. Not fuck CNN. We're not going there. What's a website that I'm willing to look at? What do you have for what do you have? I don't look at news websites. I'm sorry. I only do a certain kind of thing. You have any ideas?
It has to be a news website?
No, it needs to be something with a lot of images or news, or something that changes often, but also things that don't change often. You know what? We'll look at this. Let's go to the GM. I'm pretty sure that they use stuff like this. All right, so we'll put this up here, and then let's come to our network tab. Refresh. Okay. All right, this is your website. Let's come to GM here, and now let's take a look. And we're not going to look into this much because it's late. So we see here that GM, your main marketing site, uses HTTP version 2.
Right.
And we see here that the size transfer is 31 kilobytes. However, it's actually closer to 200. And then what else do we have? Do we have any cache control? We do. Here, max age equals 0, no cache, private. Okay. We also have this X-frame options, same origin. There's also a cookie. Now, this doesn't look to be a Cloudflare cookie, but we can go and check the storage here and see if they have a Cloudflare cookie. here's how I know if it's Cloudflare. Generally, it's going to be CF, and then like it's generally Cloudflare. It doesn't seem like y'all are using Cloudflare. I got a message. Should have cache header. Wait, look at the image. Should have cache header transfer column. Oh, okay. Let's go back to our network. And we're gonna look. You see here where it says initiator. You see all of these things. There's a document. There's a style sheet, scripts, style sheet. We also have this image here. So let's look at the image. And we see. Wait, where's the? Well, here's the response tag. We have an E tag. This is used for. If the E tag doesn't change, then we know that there's no need to make the request, or that the server doesn't have to respond with the request or response.
Oh.
Another way of saying that is, say for instance, you hashed all of the images on your website so that you produce a value based off of the content in that image. That is to say that that value will not change unless that image changes. So let's say that I send you an E tag, which represents content in your system, and then you're like, well, yeah, I still have the same E tag, it hasn't changed. I now no longer have to send you that image, which could be megabytes. It's just like use the one that you have.
Wait, is this for like when they make updates to like the website for like replacing an image?
Yeah, like if
Because
they
this wouldn't be wouldn't be like us users making a update to an image, right?
Well, exactly. Yeah, this is GM. Yeah. Yeah. So we can't. I mean, if I could gain access to your systems, I could make changes. But in general, no. Like this is me, the user, the client, connecting to your server, and I'm sending some information to you so that I no longer have to request for certain information from you because I already have it. So it limits the amount of bandwidth back and forth like that I have to do as a result.
Okay, so only if the website gets updated with like a new image or something, that E tag changes, then it refreshes on your side, like the user side.
Yes, except I don't want you to use the word refresh because it only happens when like a request comes in. And it's seen that the E tag has changed. So then the browser is going to say, oh, well, this E tag is different from the one that I have. I'm going to go and request this content because I know I don't have it.
Okay, so it doesn't automatically do it. You have to do another GET request.
Yes. Because remember, like how would the server know to tell you that an image has changed without you first
initiating?
Yeah.
Gotcha.
So I think that's a key insight for you to keep in mind, that HTTP servers are request driven. They don't just do stuff. Like they sit and wait until a request comes in, they process the request, and they return a response. And then at that point, it's over. Connection closes and the server is back at a wait state. And when another request comes in, it'll process it and then send a response, and it's done. And that's technically what throughput is how many of those, like how many requests can it serve within a certain period of time. Because obviously, if you're doing stuff, there is processing that's happening, which takes time, which will necessarily reduce the amount of throughput that your system is capable of. And there are ways to increase that. Generally, it's to add more machines. Just throw more hardware at it. But also there's stuff that you could do on the software side to a point. Like you can optimize your stuff so that you're not doing unnecessary work, or maybe you're not doing things inefficiently. You're using the best, or not the best, the optimal algorithm for the thing that you're trying to do. So let's say, for instance, for whatever reason, we're going to make up a weird example. You have 1 million things on your server, and it's like you have to find something. You have to sort through it and find it. You could do that naively, which is just go through your entire thing, your entire list, until you find the thing.
Right.
And you can do that every time. Or you could do it a little bit more smart, and you sort it, which allows you to exploit the fact that if things are sorted, you can do a binary search. So you go from an order of end time to an order of log end time. So for a million, log of a million, and this is all base 2 because it's binary, 2 binary. Log of a million is 20. So 2 to the 20 is about a million and some change, or it may be 10. Don't trust me. Let me see. 2 to the 20. No, I'm right. Trust me, I'm right. It's a million. And I think 30 should be a billion and 40 should be a trillion or something like that. So you see how it scales, right? Like if you had a trillion things and you only had to do 30 lookups, that is significantly better than you have to potentially do up to a trillion lookups every single time. So yeah, this is how you can, if you've ever wondered why people are, focused on algorithms at some of the top tech companies, this is why. You're operating at scale. So you can't do things naively.
Yeah, true.
All right. So yeah, I think that's gonna be it for today, or maybe even this week, depending on how you feel. I know there's a lot of shit. So yeah, if you have questions from now, like what I would recommend you do is ask them in the general channel. I know we don't really use it, but put it there because Yanni will see it as well as Kyle and maybe even whoever. I think I don't know who. I think you may be the only person with access to that channel now that I think about it. We'll just put it there for now. I'll direct people to go look at that. If they can answer your question, they will. If they can't, then at least they'll learn something, because chances are you're not the only person who doesn't know this stuff. All right. So yeah, how you feeling? You good?
Yeah, it's a lot of information. But I'm sure some of it or a lot of it I need to revisit. Kind of like the for in, the for of. Just because I don't think I actually learned what that loop is before. So I just need to revisit.
Well, here's a fun fact for you. This stream, this live stream, that I don't know if you realized that you're on my live stream. They go to VOD. So you can literally you can just go to my YouTube channel and you will see the one that just happened. It's today's date. And you click that and you can revisit all of whatever you've just seen.
Right. Yeah, I was thinking of that too. It'll be good to have the recording and be able to go through it again.
Well, it'll be there as soon as it ends. Literally, it's it's instant.
Gotcha.
Yeah. So you can, even now you can go in and rewind. But yeah, yeah, do that. And I suppose I'll see you maybe next week, maybe potentially. There's a chance that I might be going somewhere. We'll see. But
Oh, okay. Did you finally decide on where?
So it came up potentially Las Vegas, but I'm I can't spend 3 nights in Vegas. I just know I won't. So I was maybe San Diego, and then it came up about Savannah, and then it was Charleston, then it was Mexico, then it was potentially the Virginia Island, I don't know, Virgin Islands, and then it was let's go to not Cuba, what was it? Trinidad Tobago. That was actually I don't know, I might go to that. I want some food. I will see. We'll see. But I have to spend 3 nights in a hotel to get my status for next year, and you know how important my status is to me. But I also have 5 Sweet Night awards that I have to use. They expire this year.
Oh.
Yeah.
Wait, you can't use it on the same trip?
Well, yeah, but I don't even want to go anywhere right now, to be honest. I would prefer to stay at home, but yeah, I would prefer to not lose my Sweet Nights, because I had to stay in a lot of hotels. I had to stay a lot of hotels this year to get those 5 Sweet Nights.
Gotcha.
Yeah, and then there's flight credits that I have that expire. Basically, it's all happening within the next 2 weeks. So it's either I'm going to go somewhere, I'm just going to say fuck it and just say I don't care anymore and just lose it. Except for the status part. I do need to do the 3 days. So yeah, well, maybe I'll do that soon.
I'll just reach out and see if you're in town.
Yeah, that's probably the best bet.
Yeah. I always appreciate it. You know, like when you help out. I know it's pretty late, so
Yeah. I'm gonna go eat because
yeah.
I'm
Thank
hungry.
you
I
so
haven't eaten.
much.
You have a good night. I'll talk to you later.
Thank you. Same to you.
All right. Peace.
All right, bye.
All right. So that's that. Maybe I don't know if y'all followed that, great. If not, you can ask questions in the comments. I can try to answer them. I will be honest that I don't know. Maybe I do know a lot about. I don't know. I don't think that I know much about the web because I don't. That's not my focus area. However, do understand all of these systems because of reasons. I had to. I used to do security type stuff as well in the past. So like there are certain things that I know and I don't understand why I know it, but I know it because at some point I used it. So feel free to ask whatever. If I know it, I'll tell you. If I don't, I have no problem telling you I don't know. I say that often actually. So I'm gonna go ahead and go. I need to go eat food. I'm hungry. So I am going to call it a day, or a night rather, I should say. I may be back tomorrow, maybe. Whether I don't, well, man, actually I have a lot of stuff I gotta do tomorrow. Yeah, I may be back tomorrow. If I am, I'll probably work on the YT Slack bot because I haven't worked on that in a while, and I need to get some more of that work done. And maybe on Saturday, maybe I might do like that stream where it's like it has nothing to do with tech. It seems that people enjoy those more. I get a lot more engagement, which is interesting. So I may do that. Now, if y'all want to see more tech stuff, like do let me know because the end result is I will just stop doing it. Because like I was saying, and when I was talking to them, it's like I already know this stuff. It doesn't help me to talk about it anymore. Like I know this stuff. So yeah. Anyways, that's it. Y'all have a good rest of the night. Peace.